Okay. Hi, everyone. Thank you for making it back. We're going to get this afternoon kicked off here with the first student chapter presentation. I'd like to welcome Cal State Long Beach up to the podium to give their presentation.
Hello, my name is Arvin J. Usually we would have a slideshow. I sent you an email.
Oh, you sent me email?
Yes.
Oh, okay. Top right.
Should say slideshow, just a lecture.
Oh, okay. 1 second.
I just want to test if this is working. Doesn't seem like I can control from the slides.
You should give me the, oh. Oh, if it's online, you cannot do that. I have to download it. 1 second. Let me download it.
Yeah, sorry.
Um, Okay, almost there.
All right. Sorry, I want to.
Okay, I think you can go ahead.
All right, everyone. Hi, my name is Arvin J. And I am the CSULB Student Chapter Chair for our AIAA organization.
It doesn't work? It doesn't.
No, it isn't.
Yeah, I think this one's blocking the. Try again. Did you turn on? Did you? It's on.
Yeah.
Okay. Well, I'll advance it for you.
All right. So we would like to take this time to show how our organization has grown from 2022 going into 2023, especially at a time when we were when the new e-board has come on, and lots of the project clubs have to be reset. Our progress is poised to create a new engineering student body that is focused on projects and gaining experience that are actually relevant to the industry field. So Next slide. So before we do that, I'd like to introduce everyone that basically came here to the mini conference, most especially our e-board. You just want to go down one.
Yeah, so I'm Pedro, I'm the outreach officer.
My name is Jason Martinez. I'm the treasurer for our organization.
Laverne, I'm Andre, and I'm the club ambassador.
I'm Gordon, I'm the Long Beach Aviation lead.
I'm Cassandra, I'm the Ezra lead.
I'm Jaime. I'm the AIAA industry representative and the CubeSat lead, which is now president.
I'm Troy. I'm a VTOL proposal member.
I'm Angel, I'm the vice chair.
I'm Kiara, I'm part of AIAA and Beach Launch Team.
All right, so as you can see, we have a very large e-board because again, we want to build the infrastructure that is needed to again create these project clubs. So next slide. So first of all, what is our club? Basically, our mission is to create pathways students can take to become engineers and to constantly raise the professional and personal standards that we adhere to. Now, being a new e-board, we had a fresh perspective and we got to talk to a lot of students. And the very first thing that we noticed is that many students are eager to take the next steps, the extra steps that basically take them out of the classroom setting and into the real world experience where their expertise is constantly being challenged. So our short-term goals is to meet these needs by restarting these project clubs that have basically been neglected for I don't know how many semesters, and recreating these communities where like-minded people can actually work on projects. And we also want to further the passion that these new students by getting them introduced to the industry through speakers, tours, and the end projects. So next slide. So,
Arvin,
so to talk about our growth and our funding, I'd like to.
so as Arvin mentioned, our branch underwent a complete change in officers. And so our goal was to implement a plan to have a better source of funding and not completely rely on our university for money. And so first I'll talk about our memberships. Since fall of 2022, last year, our membership growth tripled in size, and our sources of funding will includes membership dues, fundraisers, which is merchandise and restaurant fundraisers, sponsorship packages, and I want to give a quick shout out to Pedro, who got us our first real sponsorship outside of CSULB, and that was through sending sponsorship letters to his connections. And so we have sponsorship packages, and lastly, we have ASI grants. ASI grants is it's a main source of funding for most engineering orgs on campus. And ASI stands for Associated Students Inc., and they're the student government body at CSULB, and so they help orgs with their problems and their sources of funding through grants. And we're currently working with our advisor on that on those grants as well. So yeah, next slide.
So we have workshops, GBMs, and outreach events. During the GBMs, we like to inform our members about updates that we're doing, whether it be projects, other events like the job hunting workshop, or we're doing tours as well. That's what we do there at GBMs. Just educate our members, whether it just be updates or by also bringing in guest speakers to educate our members about aerospace engineering. I want to shout out Ian. He came a couple weeks ago. We'd like to invite CSULB alumni to come speak to our members to inspire us, just so we know like what we can do. And when it comes to inspiring, I like to do outreach events as an outreach officer. This is me going to Starbase and Los Alamitos. I basically taught them about aerodynamics and what it's like to be a pilot. I'm like a pilot in training. But yeah, we're very grateful to have the opportunity to inspire and educate the next generations of STEM students. Next slide, please.
All right, so as I've stated before, our main goal for this as I've stated, our main goal for this semester and within following next semester, we want to grow these project clubs to give people more experience again in the industry, or at least in a less classroom orientated field. So here are our three main project clubs. We have Ezra, which is mostly focused on rocketry. Long Beach Aviation, which is mostly focused on building RC planes and designing these planes or aircraft. And then we have the Cube Satellite Project, which is mostly focused on constructing miniature scaled satellites that could potentially work out into the field.
So, well, once again, I'm Cassandra, and I am the Ezra lead or Ezra president. Ezra standing for the Experimental Sounding Rocket Association. So the goal of our club, or our main purpose, is to offer undergraduate students an opportunity to conduct research, gain experience in advanced rocketry, and to offer them a pathway into participating in naval projects. So we usually offer our club to third or fourth years, just because they are taking upper level courses like propulsion, thermodynamics, fluid dynamics that they can then apply into our projects and then offer a fast-paced workplace and a quicker output. So currently we're coming towards the end of our first project. We have built a test body that is able to implement various propulsion systems. Currently we have a solid propulsion system, but we can later implement a liquid bipropellant system if we like, or even a hybrid, or we can even implement various payloads such as a CubeSat if you like, or even a drone, just because we created our body to be very modular and very adaptable. So our goal for this semester is to launch our rocket and test our body and see if its structural integrity is maintained and it's able to have a safe recovery. Once we determine that our rocket is good and we're able to recover it perfectly, we will then move towards entering competition. So competition we're looking to enter in is the FAR competition or the Friends of Amateur Rocketry alongside here in California, where we can either again implement different propellant systems or various payloads if you like. And just to mention, some of our former alum have even gotten jobs in industries such as ABL, Rocket Lab, and just recently Blue Origin.
So, I'm Gordon, and I'm the lead of Long Beach Aviation. For the section of Cal State Long Beach AIAA that's focused on designing, building, and flying aircraft, specifically small scale fixed wing drones. And we have build days and flying days. Field for members.
You're not ready.
So this semester, we're pretty much going to be focusing on all aspects of just getting an aircraft in the air. We're working on the aircraft design right now. To the right, that's an example of a CFD simulation that we did in X-Flyer 5 of a possible wing configuration. Oh God.
Sorry. I'll try to give you another mic.
That's all right. I don't need the mic. So no, I'm good. Thank you. I'm sure.
It's for the people online mainly. If the people online can hear you, that's.
Yeah, they cannot hear you.
Oh,
Microphone
okay.
is there.
Oh, okay.
Or just project your voice.
Yeah, I'll project my voice a little more. So we're also going to be focusing on manufacturing. For our aircraft, we could manufacture them from anything out of like foam board and plywood to vacuum molded composites. We're also going to be focusing a bit on 3D printing, mainly non-structural parts. And the flight side, we're going to teach new members basically how to fly these scale aircraft, and we also have a first-person view system.
Quick question. Sorry, where do you fly out of RC-wise?
Oh, RC-wise, right now we're looking at a couple different locations, but mainly we're planning on flying out of El Dorado Park.
Copy. Thank you.
So this is our schedule for the rest of the semester. We're planning on having at least a test demonstrator aircraft done by early May and a flight test done by the end of the semester.
Hello again, my name is Henry. I'm in charge of the CubeSat project in our AIAA chapter. Well, what is CubeSat? CubeSat is basically a subscale satellite that basically fits in the same role as a normal satellite, but at a much cheaper price. And then as well as like when launching a rocket, right, you don't have as much payload space and or mass to take up there. And so that's why CubeSats are made. As of now, we kind of just started last month, and we're in the phase of just starting our PDR. Next slide. In terms of like the purpose of the project at our school is really just getting a lot of people experience with satellites, since a lot of the people on campus don't really know too much about it and really are interested. Currently, our mission purpose is mapping out the space debris out there in space, possibly testing with ion thrusters and communicating with other satellites. And then our like size is 3U. If you don't know what U is, it's 10 centimeter. 3U is 30 centimeter by 30 centimeter. And yeah.
So we've done a lot in the past year, and we're passionate in every event that we hold. But to highlight some of the events that we have for the rest of the semester, we have a general body meeting with guest speakers from Relativity, as well as tours Relativity Space in Long Beach. As the outreach officer, I really want to highlight our outreach event for City of STEM. City of STEM is an event hosted by the Columbia Memorial Space Center in Downey. This year it's going to be in the Los Angeles Historic State Park. We're going to be there just showing off some of our projects like Ezra, LBA, maybe CubeSat or SharkSat. It's going to be an all-day event. If you're free April 1st, I would encourage to come down. It's really cool. There's a lot of organizations from all across the country coming through. And also we're doing the SoCal Air Show, where we're going to be going as a board to go watch the plane fly. Next slide, please.
So our focus moving forward is to expand our network as a professional and technical engineering club at Long Beach. We intend to do this by collaborating with different organizations on campus, not just engineering, but non-engineering as well. By building professional relationships with outside organizations and companies, we can gain different types of opportunities, such as internships and different advice from different industry speakers. And we also intend to engage in more outreach and social events to retain a connection with our members and community. We also want to provide more resources to our members to ensure that they have a successful transition to the workforce. Internship opportunities is something that every student engineer would seeks, and we want to present that to we want to seek those opportunities and present those to our members. We also intend to provide more tours, workshops, and industry speakers for our members. as well as create an easier student and project pathway system for our students. As you can see to the right, we had 1,200 students enrolled in the College of Engineering at CSUOB. That was last fall, and we intend to reach more of those students by the end of this semester. And I believe that if we follow these goals, we can present to them the different opportunities that we have on campus, and that's going to be our goal moving forward.
So that concludes the our presentation. If you would like to contact us, this is our information, as well as on the previous, the second slide, our personal information. And we'd like to give a thanks to the LALB Section Council for helping us try to rebuild our organization, as well as the members who have stuck with us so far. These members have really helped us out and really have, again, shown that they want to take the extra steps, especially when building our organization. So that will be all. Does anyone have any questions for us? Oh, yes.
Do you have any faculty advisors?
Oh, yeah. Our faculty advisor is Dr. Yoon-Jung Chae. She's an assistant professor who mainly works in the discipline of aerodynamics.
So you're on your own for CubeSats?
Yes. We're trying to ask professors if they have any experience, and so far they have all told us that they're busy. They're working on their own projects, and they're mostly focused on their senior projects, which is actually like the projects that like seniors immediately go into. And what we want to do is that because that jump between juniors to seniors immediately dives into a project where many students wouldn't have like basically faced a project they've been in like a classroom setting their whole entire college career. We want to make that easier, that jump easier for them, that curve more smoother. So that's why we had the CubeSat project.
On your CubeSats, because a lot of people are doing what you're doing, which is cool. This is a good way to get your feet wet, right? So, but at NASA, they actually have go-bys, and how do you get it certified for space application and everything? If you go to the NASA site, you can find every link and every document for certification, testing, every B&B, everything you need to do. So that, and also that systems engineering handbook that I always brag about, everyone should learn everything in there. You'll have to follow that too if you want to certify it for launch. Okay, so just go to the sites there. Don't worry about your too busy taking care of themselves and help their fellow man teachers, right? So you guys take the initiative yourself. Go to the NASA websites, and they actually have centered document control areas where you can get everything you want. Like if you want to do electric VTOL for FSA certification, well, the F-57, they already did all that. They have every step to do to get FAA certification, and they've worked with the FAA. So it's usually led by our buddies at NASA Glen, Ohio, right by Wright Patterson, right? So anyway, just laugh at the professor next time they're too busy for you, and then teach them something they don't know, right?
Yeah, that's actually that's very insightful. Thank you for telling us about that.
Yeah, it's all there. It's just teachers. I don't even think teachers know. I think they're just out of the loop because you're either doing it or talking about what you read about.
So, just you're talking about CubeSat, I spent 20 years building satellites. So
Yeah, you would.
if you want some advisors, I'm here to help.
That would be
Awesome.
That would be awesome.
Yeah, I
And
mean,
what's your name?
Dennis, Leon.
Dennis Leon.
all right.
Thanks, Dennis.
Sure, absolutely.
Dennis will be speaking later today.
Oh, that's me. I mean, right now I'm on in my head. You know what I mean? But I'd like to thank you once again for like reaching out to us, giving us your support. When I started the sport, I think all of us can attest that this club was not in a state that should have been kept. Hopefully, I don't see the recording from any of the professors as we've been talking about
On here.
on here, except for Che. I think Che's been a really good advisor. But Yeah, if you guys have any interest in supporting us, we would love to hear your feedback. We want to hear what you've been doing, so that way maybe we could copy that system over. And like maybe in the future, our schools might be able to interact more with,
Do you have an aerospace 3D model of the Earth that you could work on? If NASA gave you one, could you do some modeling for us and learn how to do some cool satellites in space that can really do some magical stuff?
so something like similar to like JMARS, but for like Earth?
Nah, that's what I talked about last week.
Oh.
It's a huge program, 10,000 satellites.
I mean, does anyone else have anything that they want to add? I don't want to like keep any comments. No? All right. Well, I'd like to get to know more about you. What's your name?
Dennis.
Dennis and
Sean.
Sean. So I'd like to talk to you more after this, but I don't want to keep everyone else's time. So thank you again for hosting us.
Thank you, Cal State Long Beach.
Yeah.
Great presentation. Good to know you guys have a good path forward. Next up is UCLA.
Hello. Is there somewhere I can click, or should I tell you that?
It's on the.
Honestly, the CPS wants to hear what
One second, walk up.
Yeah, a bit too crowded.
Yeah. And plus we can focus on the projects.
Yeah, good call. Yes,
Yeah, go ahead.
Cool, I'm just gonna test the controls real quick. No, I don't believe that's working. Oh, that's, I'll just tell you that's change size.
Okay.
Probably easier. Hello, everyone. Hello. We are AIAA at UCLA. Thank you so much for the invitation. First of all, introducing who I am. Next slide, please. My name is Zihao. I am a senior aerospace engineering student at UCLA. I am the president of our AIAA branch, and as well as the project manager of the Design Build Fly competition team. Next slide, please. So for AIAA at UCLA, we're the largest aerospace society on campus with more than 350 students spanning across our events and our projects. Our total operating budget across our projects is around $200,000 every year. Very cool. We have three main focuses for our AIAA branch. First of all, professional development. So getting our students the experiences and opportunities they need to network with industry professionals, coming to events such as this, that they can get exposed to more opportunities out there. And then as well as academic support, a huge part of college is going through the classes, and we do what we can to help out with that. And last but not least, probably the most important part of AIAA at UCLA are our technical projects, and you'll get to hear more about them in the coming slides. Next slide, please. Summarizing some of the key events that we hosted and helped host for this past year. We had a career fair at the beginning of the year with almost 500 attendees in the School of Engineering, as well as other STEM majors. And we had more than 20 companies present with more than 60 representatives there. We've had young professional panels inviting our alumni back to speak with us, and that's to inspire our students to see where they could be in 5 to 10 years. We had multiple of these events. We also had mentorship programs with more than 120 mentees and more than 30 mentors there. So a good ratio fun events with the mentorship program as well. We've also had info sessions, both with SpaceX and Moog. We are looking to expand our professional network and get more info sessions set up. So if any of you representing companies here and want to get more in touch with UCLA, feel free to let me know during the intermission, and we can talk about potential info sessions. Next slide, please. And just yesterday, we hosted a professional development workshop, helping out a bunch of students with their resumes, cover letters, interviews, portfolios, that kind of stuff. We do what we can. The job market is competitive, but we do what we can to help out. And we are looking forward to a Spring Connections event where we're going to have our students connect more with industry professionals. In terms of other events that we've hosted, we've had social events for our students to bond. We've worked with the Society of Women Engineers on campus to promote more diversity in our engineering groups. We've collaborated with a AIAA branch in San Jose for a school visit, and we are working actively in community outreach and to host more events in that area. Next slide, please. Next up, we'll have the technical projects each talk about the things that they're working on. So next slide. First of all, from Design Build Fly UCLA, we'll have Ian.
I'm okay with the microphone, I think. Hello, everyone. My name is Ian Pasquale. I'm the Professional Development Officer at AIAA, and then I'm also the Computer-Aided Design Lead for Design Build Fly at UCLA. I also wanted to introduce Aiden. He's our Aerodynamics Lead, and Zihao, again, is our Project Manager for Design Build Fly. And for those of you who don't know what that is our Plane Engineering Club on campus. And we have three main missions. The first one is to promote the application of theoretical engineering skills, focusing on hands-on technical experience rather than the theoretical things that we learn in the classroom. We also want to provide a space for students to develop technical and leadership skills that will prepare them for working in the actual industry. And we also want to represent the School of Engineering at the AIAA Design Build Fly competition, where we're given a new set of design challenges every year to compete against a bunch of international universities at a place, normally Kansas or Arizona. So yeah, and then next slide. This was our plane last year. We named it Lazarus because it crashed and then we had to rebuild it in a day. So that's why it's Lazarus.
Okay. Came back from dead, huh?
Yeah. We did really well. We got 6th place in the design report and 16th overall after all the missions, which is the best we've done. And I don't know exactly how long.
Since 2008.
Yeah, since 2008. So definitely trending upwards, and we're hoping to do even better this year. And then if you go on to the next slide, I assume some of you guys might know this, but the challenge this year is to either have a shipping container with a certain amount of weight, and then we also have a challenge where we have to assemble the plane in about 5 minutes. So we have to design it with removable wings. And then we also have maximum takeoff distances and propulsion battery energies that we have to work around. So our 4 main missions, the first one is the ground mission, where we just have to load as much weight onto the plane as we can. The second one is proof of concept, so no real challenges, just flying the plane. The third is a surveillance flight, so having the package inside the plane while it's flying. And then the fourth one is just having a jamming antenna or a PVC pipe attached to one of the wings, chosen randomly. So those were our challenges for this year. And then the next slide. So I don't want to give up too much about our design. You know, it is a competition, and there might be competing schools here. But we have had a very successful year. We've had about 5 fly days with over 20 successful flights, and we've built about 4 prototype aircrafts, which means that our timeline for designing and building these planes is much faster than what we've done in the past. So we get each prototype done in about a 6-week time period, which is like relatively for us pretty fast. We also have an R&D team this year, and they were very successful in designing our first ever flying wing that we built. So that was really exciting. We also have Aiden actually designed or led the design of the custom wing airfoil designed on X-foil. And then we integrated data collection using GPS, pitot tube, other sensors, and then also having onboard cameras so we can see what it looks like in the air. So upcoming, we have 5 scheduled flights, I believe this Monday. So hoping that all goes well, weather permitting. And then we have a final design review in early April, and we're going to competition in Arizona shortly after that design review.
When you go to Arizona, are you competing with a lot of other schools too?
Yeah, so normally it's about 100 schools, and then there are schools all the way from like Singapore who come and like fly their.
That's the main mission.
Yeah.
Kick some butt. Is that in May that you get to kick butt?
It's in April.
Oh, in April.
Yeah.
Wow, you got a crown.
Yeah, I know.
So you're on the way, guys. Wow, that's awesome.
Yeah, and then these are a bunch of other events that we've done this year as well. We started a brand new E96 program last year that I had the honor of teaching that. So that was super fun. We also have a focus on training our new members, so giving even like freshmen a lot of experience just through like a 10-week course, like teaching them SolidWorks, MATLAB, and all those other things that we use to design our plane. And then also we have a lot of community and outreach programs. We work a lot with the Society of Women Engineers, and we have a bunch of outreach programs to local K-12 schools. And we've also worked with UCLA for First Thursdays. So yeah, this is our contact information for Design Build Fly, and I don't want to take up too much time, so the next slide should be Rocket Project, I believe.
Heck yeah.
Yeah.
All right.
Thanks. Hi folks, we're Rocket Project at UCLA. Yeah, so our mission is that we're dedicated to building the next generation of aerospace engineers through education and achievement in rocketry. So basically we design, build, and launch 1 rocket per team each year. And so we have 2 teams, Ares and Prometheus, so that's 2 rockets each year, which is very cool, both high powered. So we also introduce K-12 students and over 130 new members to rocketry every year.
Thank you, Kate. Right, so as Kate said, we have had a lot of project growth over the past few years. We originally were founded in the 2000s, I believe, correct me if I'm wrong, 2008. And since then, we've had quite the growth. Earlier on, we had about 30 active members, about 1 launch per year, and only 2 hot fires, or static fires, which we did at the Mojave Desert at the FAR facility. Nowadays, it feels more like 3 to 6 hot fires a year with 3 launches a year. 15, correct me if I'm wrong. We actually go out there quite often to test our rockets, and we have quite a few rocket flights each year. So if you go to the next slide, please. Thank you.
Yeah, so the pathway typical students take through our club is freshmen and transfer students will go into Engineering 96 Rockets, which is a UCLA course taught by undergrads such as myself. And we teach them how to make small solid rockets. And the final project, instead of having a boring final exam, they get to build this from scratch and design from scratch this solid rocket that they go out and launch, which is very cool, G-class. And then Prometheus is our hybrid rockets. That's for like after you go through the Engineering 96 class. And then after you've done a year of Prometheus, you can go on to Ares, which is the liquid rocket. It's more complex, way more powerful. So very fun.
Next slide, please. Thank you. Oh,
yeah. So RISE, Engineering 96R, yeah, it's an undergraduate taught class. We offer 4 sections in the fall, so that all of the students who want to can hopefully join. And students get the opportunity to, make and launch 2 rockets in groups. They also learn about Rocket Project and the aerospace industry and what subsystems they're interested in. No experience required. We teach everyone every skill that they need to learn. And it's a super great way for students to get a head start on all that.
Isn't it the coolest feeling when your first rocket launches successfully?
Yeah.
It's like,
oh, it really is.
Literally.
It's something else. Speaking of which, let's talk about our projects. So as Kate said, after students are done with their Engineering 96 course, which usually spans the length of fall quarter, so just 2 to 3 months, for the rest of their freshman year or new student year, they enter into the hybrid rocket power team, or the hybrid rocket team, which is, I'm the project lead of which. We build these rockets in about 5 months. That's the length of our design cycle. Our rocket is hybrid powered. We shoot for 10,000 feet, and everything we build is nearly entirely in-house manufactured and produced, even including our engine. It's not on the slides here, but we typically compete at Spaceport America Cup. This year we'll be competing at the FAR competition in June 2nd, I believe. So it's coming up quite soon, and we just began manufacturing last week. Anyways, a part of the liquid bipropellant team, we currently hold the record for the highest liquid bipropellant spaceflight in the country at 19,000 feet, and we're going to smash that record out of the park in about 7 days when our liquid team launches this weekend.
Or how high? 45,000?
This year it's 30,000 feet, but typically it's been 45,000. No one's ever been able to reach it. Any college, any student-run organization in America, we hope to make it done this year.
I hope so too.
Fingers crossed.
Make it happen.
Right, so a bit more about Project Prometheus, aka the hybrid power team. Our goal essentially is to build and design this hybrid powered rocket from scratch every 5 months, every year. It's also to prepare people for the liquid bipropellant team, which is a mechanically more complex system. So just to give them an introduction and a preview of that. At least in stats for Prometheus, we've had about 12 static fires in the past 3 years, and we hope to have 3 more within the next 3 months. As well as finishing second place in the 2018 Spaceport America Cup competition with the, again, fully student-developed hybrid system. There are currently 85 members, active members in the team, with about 130, 140 on paper. But with 85 active members, we can get a lot done, so we're more than grateful for it. Next slide, please. Thank you. So Project Ares is our liquid bipropellant team. It's currently one of 7 universities in America that build this rocket, period. And we have about 50 active members in that project. We hope to cultivate experienced rocket engineers through this design, build, and testing of a fully liquid bipropellant rocket by focusing on an attainable rocket within a 1-year timeline. For reference, other competing universities usually take 2 to 3 years, whereas we get this done in about a year, or in the case of our hybrid system, 5 months. Next slide, please. We also have an R&D team. This is a smaller side of rocket project, but we have notable achievements, including current developments in gimbal thrust, which we may implement into our hybrid-powered rocket in future years, as well as the possible implementation of control surfaces and a turbo pump, which is pretty standard in industry, yet no college team has been able to create one and implement one on the launch pad. So we hope to break that achievement sometime soon.
Yeah, we also have a great youth outreach program because, not only is our goal to make sure that rocketry is accessible for like freshmen and students, we also want to make sure it's accessible for like young kids in the community. So we organize trips to schools in the LA area, especially for like underserved schools, and we also host events at UCLA. We also had a great virtual outreach program, especially during like the pandemic when it was in its height. And that was great because we got to reach schools all over the nation, not just in our community. So that was really cool. And then and now we have this hybrid model with a virtual and in-person visit. So we've really been able to expand our outreach, which has been really cool. Thanks. And here's some photos from outreach. Thank you.
Alright, hello everyone. We are Uncrewed Aerial Systems at UCLA, or simply UAS at UCLA. So we kind of differ from all the other teams in that we work on drones and that they also fly, but they fly by themselves. So one of our big missions is that since the drones fly by themselves, we have a lot more diversity in our student body, from not just mechanical and aerospace engineers, but also computer science, computer engineering, electrical. So one of our big missions is to make sure that we can learn in multidisciplinary teams and that we can apply and learn new technologies that is kind of at the forefront of industry. So we also build, prototype, and fly our own drones that we typically build in-house or some form of that. And one of our big other missions is just inspire and introduce all students to the field of aerospace and also autonomy, because drones is kind of the next big field. So we want to get more people into this sector. Next slide, please. Thank you. So the big competition that we do this year is the SUAS competition, which stands for Student Unmanned Aerial Systems. And in this, our mission is a bit different from all the other ones in that we need our drone to fly autonomously for over 12 miles this year. Also avoid other obstacles in air traffic because we'll be flying in the space with also other drones, so we have to figure out how to avoid them and not collide. We need to identify ground targets that are basically shapes such as the one you see there in the blue triangle with an A in it, and they're about the size of a normal letter paper. So our drone will be flying around 100 feet in the air. We have to have a camera on it in order to find where they are, locate it, and then we have to airdrop some cargo onto those targets, which are pretty hard challenges. Sorry, go back, please. No. One second. Yeah, so our drone that we're currently working on is a fixed wing, and we chose fixed wing so that we can meet the requirements of flying 12 miles. We'll have 3 cameras, one pointing down, 2 pointing forward to identify targets and also other drones. We'll have payload pods for our cargo, and yeah. Cool. So for this competition, we have 3 sub-teams. 2 of them are more computer science oriented. We have one that's computer vision, and they work on the target detection and identification. So they work a lot with computer vision, such as OpenCV, and also a lot of machine learning models from CNNs to, and object identifications. We also have a flight software team that works with the autopilot scripting and also communicating with the drone through the ground station. And they also work on path planning, obstacle avoidance, and a lot of the software integration side of things. Lastly, we also have the airframe, which works on building the airplane itself. So we go through a lot of the hardware design, CAD, and manufacturing, as well as building out the plane. So a lot of these are pretty complicated skills, and we don't expect any of our members to come in with any of these skills. We hold a lot of workshops that go through from learning how to use Python from the start, or also to using like TensorFlow or other machine learning models, as well as teaching CAD and other important manufacturing technologies.
Like the other clubs here, we also have our own E96 class, which is a student-led design class. So for this one, we teach our students all about drone design, quadcopters specifically, although they have the option to try to do hexacopters if they'd like. We just go through like the basic flight mechanics, and we teach them just about what goes into the system of the drone, like the avionics, as well as all the hardware. And through the 10-week course, they design, build, and test fly their drones. This past quarter, we had all 5 of our student-led groups successfully fly their drones, and most of them were able to actually do the payload drop as well. That's a new thing that we've incorporated. So yeah, it's open to all students. We'd like to encourage freshmen to get involved, especially those who don't have hands-on experience. As we've mentioned before, there's not a ton of opportunity for hands-on experience outside of clubs, and even then, it's not usually in a super structured way. So these E96 courses are a great way to have a structured introduction to the way engineering works.
Good job.
Yeah, we're UAS.
Yeah, this is our contact info.
Yeah.
Next slide, please. Yeah, lastly, I'm the president of Burn Spacecraft Group. We are a club dedicated to, next slide, making space accessible and its technologies accessible to all students. We build spacecraft, we have high altitude weather balloons, host workshops, have company info sessions, all for the purpose of having an opportunity and a community of people that are able to explore space and basically have the ability to build industry transferable experiences and get involved in certain projects that will benefit them in their career. So these are some of the highlights that I wanted to point out for our CUBE satellite, our high altitude weather balloon, as well as some of the other workshops and like programs that we have as part of our club. Next slide, please. So our 2 main projects are our CUBE satellite, which this year is working on a 3U CUBE satellite hosting an ion thruster and using in-house magnetorquers for ADAX control. And our secondary program is Overseer, which is our introductory level engineering program, essentially designed that if you have only the basic high school science level experience, you should be able to get into the program and understand the basics, getting electronic circuit experience, some actuators, some soldering, and other mechanical skills, other software skills, everything that you need to do in order to have the experience in order to join our CUBE satellite project.
Is that the balloon that Biden shot down?
No, actually, we were not able to have that pleasure of having it shot down by Biden. Next slide, please. Yeah, so in previous years, our CUBE satellite actually made it into orbit on board a Blue Origin space launch provider, and we had the opportunity of testing a magnetohydrodynamic pump. All of our missions are based on the idea of doing technology demonstrations and scientific investigations. So both our CUBE satellite and our high altitude weather balloon are on the premise of projects for passion and projects for the exploration of new technologies and sciences. Next slide, please. We also have more, if you aren't necessarily involved in our projects, but still want to learn about space, we have opportunities to learn about not only the tools and skills that you need in the spacecraft industry, but you can also have guest speakers. Just this year, we had a speaker come in to talk about the orbit modeling software that is commonly used in the industry. In previous years, we had basic CAD programs getting the information, the fundamental skills needed to build spacecraft and all other skills necessary in the engineering field. And as well, like I mentioned, the guest speaker that we had 2 years ago were some of the project contributors to the James Webb Space Telescope. So giving a little bit more insight on what exactly is done in the industry and how our club relates to the industry work that's done. Thank you.
All right, hacksaw.
Yes. Again, thank you so much for this opportunity to speak with all of you. And if any industry person want to reach out and help our students in any way, let us know. We're always happy to host you. Any questions for us and for any of our projects? Yes.
Yeah. For CSULB, we are more than happy to collaborate with the spacecraft technology sort of stuff because we're also kind of getting our ground back up and we're working on a pretty similar project. So I think it would be a pretty productive collaboration. Sounds great. Thank you. Thank you.
Great. Absolutely no questions. Fantastic. All right. Thank you again for your time.
Nice job, UCLA. You guys are a machine. All right, up next is UNLV.
So we have a laptop. Is that okay? Okay. Where do we go from here, Kenny? Where the next one?
UNLV.
Right here.
Yeah, right.
Yeah, we're just setting up.
Oh, cool.
I didn't see the agenda. Thanks.
I think it's because yeah, for folks online, I'm sorry because UNLV is a more physical demonstration, so we are not going to share the PowerPoint online for this one, but you can see through the camera. Sorry for that.
Avi.
All right, hello everybody. My name is Christian Yuan. I'm the president of the AIAA chapter of, I'm the president of the UNLV chapter of AIAA. And I guess since our team today is a little bit smaller, I'll do a more in-depth overview of where I'm from. So I'm currently a third-year engineering student getting my degree in electrical engineering. And the way I got into AIAA was I was just walking around the involvement fair one day, and I just saw this little booth, and they had all their airplanes out. I was like, oh, that's cool. I guess I'll, sit down and talk to them for a little while. And eventually, over time, people shuffle in and out, and that's how I ended up becoming president of AIAA. So it's kind of funny how that works out. And these are my friends and my teammates: Martin Arguelles Perez, PhD student; Jared Angelis. He's our Air Force ROTC.
Yeah.
And Erin Rokes. She's a psychology student.
Hi, welcome.
So for a history of how or where AIAA UNLV's chapter has been, in the past, our chapter has had very successful competitions. So we've gone to 3DP, we've gone to DBF, and we've had very lucrative experience with all these previous competitions. Actually, Luis was one of our former members, actually our president. So that's really awesome. And in the past we've done a lot of outreach, like volunteering, and actually UNLV has this introduce a kid to engineering day. And that's when a bunch of the engineering clubs just host a bunch of younger children and teach them some fundamentals of engineering. And that's something that we've done in the past. Other outreach events that we've done have been the UNLV Involvement Fair and also UNLV Creates, which is more geared towards engineering students. But just as an overview, this was the previous team, this picture. And over COVID, that team has all graduated, and our current team is completely new. So something that we're focusing on this semester is training new students, younger students, and making them prepared to carry on our legacy. That way, this sort of situation doesn't kind of happen again, especially over COVID when, quarantine took over everything. It was hard to keep up. So now we're just trying to focus on training new students and getting them prepared for these leadership positions. But another thing about this previous club is they are very well regarded amongst the UNLV faculty and staff. You could literally ask anybody from UNLV and they could give you an awesome story about these members. So yeah, I think it's learning about this club, all these previous members really opened my eyes to what UNLV is capable of. And it's really pushing me towards more, different avenues. Can I get the next slide, please? So we have gone to competitions in the past. The most recent one we've attended was 3DP. And actually at 3DP, in the past, UNLV has also done really well. I believe we've set a record in the past. That was the previous team, once again. And just hearing about all those previous stories, it doesn't just affect UNLV, it reaches out into University of Arlington, Texas, and all these other universities. So that's just a really inspiring thing to see what UNLV is capable of. We're also, we were participating in DBF. We had to refocus because of time constraints. So now we're reprioritizing, training new students, and we do actually have a few projects going on right now. So if you wanted to go on to the next slide. The UAS lab at UNLV is a really awesome resource that we have access to. Martin is actually the manager of the lab, and through Martin, a lot of our members are able to find jobs. Because it's such a small club, Martin, and because Martin is like a PhD student, he has so much access to so many different resources and so many different people. And he's able to vouch for us in terms of like, hey, this is what AIAA is about, and this is what they're capable of. So that's, you know, that's really a great mentor to have.
I see there's access to robotics, so I'm actually going to show you guys a demonstration of a slam capability here.
Oh, cool.
Of something we'd stick on our drones.
Yeah, so this is actually something that Martin's been working on for a little bit now. So if you wanted to start off with
Yeah, go
I'll
for
go
it.
ahead. Honestly, I'd say have Jared and oh crud.
Aaron.
Go ahead and introduce yourselves. I just noticed that some IP stuff got changed around for. I'm just gonna do some quick editing.
Okay. My name is Erin.
Hi, Erin.
Christian said, hi. As Christian said, I'm actually a psychology. I study psychology and neuroscience at UNLV, but I'm actually interested in the field of human factors, which is the application of psychology to engineering. And this is kind of like an up and coming thing that people are just really starting to like become popular. It's been around, but it's starting to like really come out of the woodworks as far as like education is concerned. And I'm really interested in actually the California State Long Beach master's program. I've heard good things about that too. But since UNLV does not have a human factors undergraduate program or a master's program, it's kind of my responsibility to craft my own experience for what I get out of undergrad. So that's why I'm doing psychology, neuroscience, and then I'm learning about engineering through clubs. And this is the perfect club. They were really accepting, and it's fun. It's really been fun.
Awesome.
Yes, so as for me, he kind of spoiled it already, but I'm Jared. I am a super senior at UNLV now, and I'm on my way out. I have 63 days till graduation and 65 days until commissioning. I'm actually going to Tyndall Air Force Base in Florida. Are you ready?
Well, actually, I just realized I'm on the wrong operating system.
Uh-oh. What is it, Windows?
No, that's the newest version of Ubuntu, but I actually have this one running on the first iteration of ROS 1, which actually requires the last generation of Ubuntu.
Okay, so you know, Martin works a lot with ROS, and that's something that we're trying to implement more into our drones and our VTOLs and all of our projects overall. Just doing like unmanned aerial systems and doing like autonomous flight. Currently, the software that's running on these two drones is PX4, which is the autopilot software that of choice that we like to use. It's very open source and it's very well documented. And the interface that it comes with, Q Ground Control, is a lot cleaner than Mission Planner, in my opinion. So yeah, that's kind of, if you haven't tried out PX4, I would highly recommend it.
Aaron, on your human factors engineering, it's a lot more than just ergonomics, right? Like,
Yes.
like if I put you up on a space station, you'll have accessibility and notes of how to make sure you can reach from one position to another, right?
Yeah, I think that's why it's important to learn about engineering terminology and know more of what you guys do versus just the experience of only studying psychology, only neuroscience. Then I'm kind of thrown into the world of working with you guys, and to not have that connection or not know what's going on, I think it's important for me to explore.
So just showing you guys a little back end. For those of you that use ROS, you'll recognize exactly what I'm doing. So right now I'm setting my ROS IPs to be appropriate because my Wi-Fi hotspot actually just decided to change the IP to a subnet. So really quick doing this.
Can I get a picture and send it to China?
You won't get much information off of this. We're actually pretty secure. I've been working for a DOE for a bit.
You should guess our password.
All right. Oh yeah. Well, it's very insecure, that system. It's almost meant for anybody to pick it up. So right now I'm just gonna run a script that I have. This makes it much easier. So right here, I'm actually starting the SLAM operation on that drone right over there. Using RTAD nav, something you might be familiar with if you've done SLAM operations in the past. And on this one here.
It's gonna fly a circle around us?
What's that?
It's gonna fly a circle over
It won't fly right now, just because I don't have it mounted on the drone, and this is actually a development kit. But I'm just launching this on RViz.
just last year. So pretty much right here, we're able to see what the drone is seeing, and it'll actually do a full mapping. However, in this scenario, for what I'm working with AIAA, the mapping isn't really the important part. The important part is the localization. So you see how we're able to get a position, the attitude of the drone. So this will enable us to do more indoor flight with the kind of projects that they're working with. And again, it is cool to see the map. So I always like to enable the point cloud. Of course, you can get a voxel grid off of this as well. But again, for the purposes of what I'm working with on
And color
AIAA.
pigmentation too, that's even cooler.
So what was that?
Color pigmentation to it.
Oh yeah, this part's like point cloud. If you do a voxel grid, it downsamples it, and you can do like object avoidance with that. But again, this is the kind of stuff that I want to help AIAA get into. And you saw that was very scrappy.
Yeah.
Yeah.
Question, if you're gonna put this on the drone, are you gonna wire it directly or is it still gonna be transmitted?
It's going to be on the drone. That is a development kit right there. This Jetson Horn is the newest iteration of the Jetson line. Right now they released the NX modules, and with that I will be able to put this in a form factor smaller than a Raspberry Pi. And yeah.
Just a second question.
Yep.
You mentioned something about object avoidance. Is this something for the drone to avoid objects?
Oh yeah,
or-
I can probably show you a voxel grid right here if I can find my mouse. So you'll see that it'll kind of downsample this whole thing if I show an occupancy grid. So this should be, oh, it didn't enable. Darn. Well, that didn't work. Well, there's an occupancy grid that I can enable here, but it seems like there's an error. It might be all sorts of things given the fact that I just messed up the IP stuff. You can start in the demonstration. But you would see a voxel grid, and a voxel grid essentially is turning this like really advanced point cloud and making it more into just cubes. Yeah. Like a 3D.
So it's not gonna hit me up my power lines or a transformer.
Oh, not even close. Not even close.
I guess what's the minimum density of, or the minimum object density it
That
can
is
detect?
true. The minimum object density.
Like if it's trying to, can it detect like a basketball net, you hold it on the ground?
Oh yeah, it
What's
should
the
be able to
deal
do
to go around
that. It'll get like more of a. It won't get individual strings, but it'll get the entire area to avoid. Yeah.
Does it have a flare in it?
Does it have a
Forward-looking
flare?
infrared?
What?
Does it have a forward-looking infrared capability?
Oh, not on this one. I do have a FLIR camera, a Duo.
That you could do something similar to that with this, right?
Yeah.
You need my card and we need to talk.
Again, I'm trying to get AIAA more involved with this kind of stuff. I tend to be very busy with all the projects that I get involved with. There's so many opportunities in robotics, but if I can get something for the club to do, for example, I hired Christian on board for a lethal project he'll be talking about in a moment. That's the kind of stuff I'm really interested in.
I have a
What is that called?
Huh?
What is that called?
Oh, this is just called ArtMap. It's an open source thing. I mean, I did a bunch of customizations to get it optimized for being on a drone, but overall, this is just basic ROS. And those of you that know ROS will know that it's very easy to use once you get it up and running. And that explains why I was getting all those jitters. All right. And let me get your slide back up.
Yay, thank you.
Yeah, demos don't always work. I just went to a conference recently, and I've seen these big companies going through the same problems I do. It's great.
So yeah, like Martin said, he was able to hire on a lot of AIAA members into different projects. One of our members, Tristan, is working on a delta arm manipulator to, it's for a project that it's for like testing soil moisture. And it's just like all these different projects that Martin's able to incorporate AIAA students in is really interesting and valuable like experience for those students.
And the presentation will be up in a moment.
Got a nice shot of Martin over there.
Oh, great. All right. You were in charge of this before. Please handle it.
Where were we? Oh, and we have a little bit. Okay, so this is actually the main project that we've been working on, or at least I've been working on. If you want to hand around the VTOL and people could like check it out, this is our prototype. Yeah. So the main goal of this project is to develop a product, with air quotes. It's not something that's actually going to be released to market, but something that could theoretically be released to market, and take the conceptualization of that project to completion of something that is a fully developed product, with air quotes again. So like imagine something that Autel or DJI would have wanted to make. That's ideally the end goal, to create something that's consumer grade. And with that, we have to go through a lot of different hurdles, like getting it flight ready, getting it like getting the different verifications for it. And on top of that, we have to do a lot of prototyping and design. So if you want to go to the next slide.
Wait, I want to also highlight something. For this project specifically, the grant actually encourages us to work with business students because this is the type of project, even though this isn't going to market, the type of things that we could potentially go to market with. So yeah, we're collaborating with 2 business students, and they're helping us with our crowd fundraising campaign and whatnot.
And actually, we could take the top off so you guys can get a look at the inside.
It's a little messy at the moment.
Yeah.
Yeah. Relatively clean though. Given his experience when he first started, that is super clean.
How long you been with this one?
With this project?
All your projects with this one, yeah.
This project specifically about 5 months. But overall, I started my PhD a year and a bit ago.
Are those fans?
Those are propellers, or they're motors, but they don't have propellers on them.
They actually tilt, so that's what gives us our, if some of you might know, if you have 3 propellers, it's an uneven number, you're gonna lose your yaw control. The actuating helps us to control the yaw control. And actually they're a little damaged at the moment because what we were doing an experiment with forward thrust. So instead of a traditional copter, what it'll do is it'll pitch and then go forward, like this to go forward. But we said, hey, we have like actuating front motors. Let's just have the front motors actuate. It did not work very well heading this way. Okay, because what happens when you pitch back? Well, you tell it to go forward, and what does it do? It's not facing vertical. The wind knocked it over upside down, so the motors are actually a little damaged. At least the holder. Yes?
A lot of airplanes can hover and cruise, but they can't get through transition.
It's tough. We're actually working a lot on getting that
Like
too.
the B-22, 20 years, we actually had a 50-year plan. All our airplanes were gonna be B-22 type, all of them.
Yeah.
They were gonna have
It's a
4,
challenge.
6, 8.
It's a challenge that we get to discover together. And now that specifically, the airframe is actually commercially available. That's why it's such nicely printed foams. But the electronics and all the other kind of stuff, that's what we've been designing, with the flight control software and whatnot. So it gives us more, that is actually an open source flight software. We mentioned it before, PX4. So it gives a lot of the students here an opportunity to get into GitHub and open source contributions.
Yeah, and I'll just put in a little word on like some of the parts we used. A lot of it was straight up hand-me-downs from the UAS lab, just stuff that wasn't being used. So it was really nice to implement those. Like the telemetry on there was just something that Martin had lying around. The GPS was something that Martin had lying around. But the flight controller is a Kakute H7 Mini. It uses a Matek PDV to power the ailerons, the horizontal, or the ailerons, the elevators, and all the PWM and D shop ports. And it also uses a Archer, an FR Sky Archer, as a receiver. There's also a walk snail because it has a camera. If you look at the front, there's a camera on board. One of the issues we encountered while making this iteration was we weren't able to get a airspeed sensor on there. There was some sort of issue with the software, so we had to we had to remove that. Hopefully in future iterations we could bring it back. So yeah, that's something that we're working on right now. Like I said, the software we use is PX4 and Ground Station. It just makes it really easy to change parameters. And they have a lot of documentation on this stuff just because it's open source. And because it's open source, we're able to make contributions to the overall
algorithm.
Not algorithm. Well, if we wanted to, maybe, but to their documentation page. So for example, they have a bunch of example airframes that people built with PX4 on their documentations page. And that's actually something that I've been working on, making a build log for this and releasing that to the public and seeing if people are interested in replicating this or like maybe altering the design somehow and iterating onto it. And therefore like creating, I guess, lengthening the longevity of this project beyond like the year that we're going to spend building it. And I guess next steps for this project, if you want to go to the next step. So currently, this is our second prototype. We've actually crashed and scrapped the first one. But currently, we're in the phase of crowdfunding. To do this, we're doing essentially a Kickstarter campaign. The goal is to raise $2,000 for this project. And we're doing this through the UNLV website called Rebel Raiser. It's just like Kickstarter, but for UNLV students. It gets in front of the eyes of a bunch of different UNLV alumni and UNLV students and different corporations that sponsor UNLV. So this is our basic timeline and where we're at right now. And these are the few things that we have left to do before we can say, hey, this project has been completed. Let's move on and let's see what else we can do. And one more thing to add on to that, like with the avionics and all the electrical hardware, one thing that we would like to do is integrate computer vision, which would be really cool. So yeah, that's just a little side note. And like I said earlier, our main goal this semester is to train new students and bring in new faces and get them ready to take on leadership positions. So that's what we've been prioritizing. Actually, Jared and Aaron are both brand new this semester, so it's really great to have them on board. And to do this, we're actually doing a drone workshop, and this is our current drone build that we've got going on. If you want to pass it around, and it's a very simple drone build. But it teaches the fundamentals of what goes into a drone, and it shows students like, hey, this is how you put something together. This is how you solder stuff. This is how you change software. So like it's rudimentary, but it's also very impactful on the student's career. I know that another student, Aaron, has been putting a lot of work into this. Just like
another Aaron.
Yeah, no, there's another Aaron. But also so has Jared. Actually, there's a 3D printed mount on there that Jared's been making iterations on. So yeah, that's just a little side note.
And the reason we chose to get a frame like this is a commercially very popular frame, is because with this, we're able to give students an introduction to modeling and adding 3D components to like an assembly in SolidWorks, Autodesk Inventor, and whatnot. Yeah. And it's just an easy soft start before we start putting them into, more complicated projects, where they're actually designing an entire airframe for themselves.
Yeah, and
we
did bring a working drone if you wanted to fly it.
Yeah, maybe later. Yeah, we want to get some aerial shots.
Yeah. But another thing we need to focus on this semester is actually bringing in new officers. Like I said, Aaron, back at home, he's a really good recruit, and I'm looking forward to training him. He's actually a freshman right now, and I'm actually asked him to be vice president, and I'm hoping he takes it up and eventually takes over my role within the next year or two when I end up, having to leave. And we have a few other open officer positions if anybody's interested. I'm just kidding. Like treasurer and social media officer. Actually, this Aaron has been doing an excellent job of managing our social media. So kudos to you, Aaron. That's really awesome. And overall, we just want to build a strong community that's able to communicate ideas and just have a good time on campus. So to do this, we're gonna try and do more bonding experiences, maybe go out to play soccer once every month, or do escape rooms. We were just talking about it today. But even this long trip this morning, it was a 4-hour drive, but that was such a great bonding experience for all of us. So
3 in the morning.
Yeah,
we're like, let's go.
It was a real grind. And we also
I want to bring up that naturally we admire to see like these large groups of other students. I love to see the projects UCLA is working on, along the beach as well. I mean, actually, I've known you guys, UAS at UCLA, because of your open source, like involvement in the past. I already knew about you guys.
Yeah, we actually met your former president, I believe, at like Las Vegas Ascent.
Yeah, to the left of Veritasium, in that picture, we met that guy.
So you actually left really early this morning through the rain?
Yeah.
There was less rain in our part of town, or in our part of the state, I guess.
I drove through a cloud.
Yeah.
But we also cooperate with other clubs on campus. So the American Society of Civil Engineers is one club that we've very recently had a lot more communication with. So yeah, we've been communicating with those members a lot more. Actually, the other day they just brought us a whole pizza, so that was pretty awesome. And also the American Society of Mechanical Engineers, they're actually working on a hovercraft. And to do this, they're using a lot of the similar parts that you would use for a drone. And we've given them a lot of counsel on what parts they should use and how they should go about wiring it. And in return, they've helped us in the past with our 3D printed aircraft. We're not the most well-versed. Martin's a CPE major and I'm an EE major. We're not the most well-versed in AutoCAD, or not AutoCAD, but just like regular CAD software like SolidWorks. So, they've helped us out a lot in the past. So we hope to build more relationships like this and keep these current relationships strong. And then I just added this little acknowledgements tab at the very end. If you look at that photo, that's actually Luis. He's the former president, of course, still on our website. But I'd just like to shout out these individuals. Adrian Rivas and Jacqueline Gonzalez. Adrian, our current treasurer, and Jacqueline, our former president. Both of them worked really hard last semester at recouping our funds and making sure we were taken care of financially. And together they were able to raise, I believe, $12,000. And just a few weeks ago, we were told that we just got another $2,000 because of the work they put in.
Okay.
I would also like to shout out Martin, my mentor. He's really awesome at training new students, not just new students, but also me. I was very introductory when I first came in, so he's really putting the work to make me a little better. I'd also like to shout out Aaron and Paul for coming, and also putting in all these hours to make for starters, make the drone a little better, and also keep up the social media page. But other than that, that's about it for the presentation. Any questions? Yeah.
I've always wondered how you handle rotor route, like in your 3D rotor configuration.
Mm-hmm. How we handle rotor?
How one rotor fails.
One rotor.
Oh, in this scenario, we just let it crash. I hit a kill switch. No, I'm not even kidding. If anything happens that is out of the ordinary, because I'm used to flying in an indoor environment, I hit a kill switch immediately. It's like a reflex. Yeah. So we have no control algorithm yet to handle a rotor failure.
But they're very resilient. I actually crashed one from 40 feet, straight nose dive. It was good to go again. So.
Oh yeah. Yeah.
Until Martin crashed it and then completely shattered.
Yeah. Battery wasn't strapped in. Yeah. We actually, one thing that she brought up, we did some 3D printed propellers based on new research happening at MIT. And the person who printed it, I don't know what they printed it with, but very brittle material. It ramped up and just exploded on us. Yeah, that's stung.
Any other questions?
All right, good then.
Well, I guess that's done.
Thank you.
Good luck in June, right?
June?
Is that when you're gonna do the big competition?
We're actually not signed up for any competition.
Oh, I thought you were gonna go to it.
Thank you, UNLV, my alma mater. Great job. Next up is USC. They're not here today, so they provided us with a video, kind of the same format as what we've been.
I'm also a member of USC Rocket Propulsion Laboratory, as well as
same stuff, same format, same style of slides. They're just going to go over what they've been doing and what they're planning on doing in the future through a video format.
Yeah, actually, that day was their final. So today,
It's the first day spring break at USC.
Hi guys, my name is Benzi Wizibo and I'm a sophomore here at USC. I'm also the president of the USC AIAA Club, which I'm here to talk about today. Quick facts about me, I am majoring in aerospace engineering, like half of the club here. I'm also from Seattle, so not a fan of the weather here, but I'll make do. I'm also a member of the USC Rocket Propulsion Laboratory, as well as also known as USC RPL, and I've been involved in AIAA since my freshman year of high school, so it's been a good 4.5 years now.
Hello, everyone. My name is Lisa Lopez. I'm the Vice President of AIAA. I'm also in aerospace engineering. My hometown is Southgate, California. And some of my involvements outside of AIAA, I am on the Trojans women's rugby team here on campus. I'm also part of the USC Curve Fellowship, which I will get more into later on. And I'm a student worker with USC Housing. And a fun fact that I would like to share with you guys today is that I can play 3 instruments.
Hi, my name is Yashvi. I currently hold the media position within USC AIAA. I basically make graphics, manage the Instagram, make and send the newsletter, and help the rest of our executive board plan events and communicate with our general members. I'm also an aerospace engineering major, and I'm from Orange County, California. I'm involved in the Society of Women Engineers here at USC, where I serve on the operations committee, and I'm also involved in the Klein Institute for Undergraduate Life, as well as Scholars Leading Scholars, also here at USC. And my fun fact is that I went to 9 concerts last year.
Hi, my name is Maggie Tran. I am treasurer of USC's AIAA student branch. I am a sophomore in aerospace engineering, and I am from Whitehall, Pennsylvania, which is 1 hour north of Philly. I am also involved in Trojan Barbell Club, USA Powerlifting, and I work at the gym. I also enjoy baking in my free time.
Hi, my name is Ian Wong. I'm currently the logistics chair of USC's AIAA, and my major is aerospace engineering. I'm from Tokyo, and some other involvements I have at USC is USC Formula SAE, which I'll talk more about later, and I'm also the co-president of USC Snow Club. And a fun fact about me is I've jumped out of a plane before. Founded in 1905, USC Viterbi is a renowned school for a variety of engineering degrees, especially in the postgraduate field, with around 4,000 postgraduate and 1,800 undergraduate students currently enrolled, making up 11% of the total population at USC. The strong Trojan family network, extensive ongoing research, and many student design teams provide vast opportunities for many.
So Viterbi offers many different programs and resources for a student to get involved in with pretty much whatever they choose. So whether that's career-related, academic-related, or even an individual project that a student wishes to work on, Viterbi has the resource for them. So some of the most well-known and most useful programs here at Viterbi, we have the Progressive Degree Program, also known as PDP. We have the Center for Undergraduate Research in Viterbi Engineering, also known as the Kerr Fellowship. Throughout the year, we also have different networking and career fair events, things in that nature. And we also have the Baum Family Makerspace here on campus. So the Baum Family Makerspace is just like an open design space. It's equipped with multiple 3D printers, different building tools and machinery, and different workbenches, all open to engineering students. And fun fact, it's also home to a couple of the design teams here on campus. And you could also see it here on the right as well. So talking more about the Progressive Degree Program, it's a program that offers undergraduate students the opportunity to basically earn credits towards a master's degree while also completing their bachelor's at the same time. And students are encouraged to apply during their junior and senior year. As long as they have about 64 college credits completed, they're eligible to apply. And to fund this project, because of course school costs money, there's many different scholarship and financial aid opportunities that Viterbi offers for them. So moving on to the Kerr Fellowship Program. So what this program does is it pretty much matches students to faculty-led research opportunities, pretty much with every single department within Viterbi. So we have aerospace and mechanical engineering, we have astro, biomedical engineering, chemical engineering, civil engineering, industrial. All of these departments offer different positions for students to choose from. And these students are awarded a stipend of $12.50 a semester, so that's always a plus. Students are also offered different career slash internship resources throughout the year as well. These pretty much present themselves with resume building workshops, networking workshops, things of that nature. And at the end of the year, students present their research at an end of the year symposium hosted by the Kerr Fellowship. And if you look at the right, you can see this is an example of some of the lab research that goes on. So this is within the AME department. They're basically testing a high performance polymer in a bending test, and then using those test results to pretty much discuss their mechanical properties. So talking more about Viterbi's networking and career fairs. So basically Viterbi hosts about 2 career fairs each year, one per semester, so one in the fall and one in the spring. Even within Viterbi though, you have many different organizations hosting different networking events individually, more tailored towards their group members. So you have like the National Society for Black Engineers, you have the Society of Women Engineers, etc. Another huge resource for Viterbi students is the Viterbi Career Gateway. So this is pretty much similar to LinkedIn. It's a platform tailored specifically for Viterbi students. This is used to connect with employers, recruiters, things in that nature. This is a huge resource for Viterbi students to get involved and look for jobs that way.
My personal favorite part of this slide deck is this part here, talking about USCRPL, which is the premier undergraduate rocket propulsion lab on Earth, I'd say, but a bit biased there. That being said, I say that we are the premier because we launched a rocket in 2019 that went to space and came back down in one piece, which is our claim to fame, our record that we hold and treasure. Either way, as a team, we incorporate a bunch of practical skills from across the industry, right? In terms of composites and structures, manufacturing, design, analysis, thermals, heat transfer, everything, chemistry, even, right? All that on top of operations and whatnot to actually manage the team and run it well. That is actually how we teach our students and our members, how to go into the field and do well and actually perform at a higher rate than some of their peers might. Either way, we are a pretty notable team here on campus just because we are, pretty large and we do a lot of really major rocket launches every year. So on the right is a picture of Jawbone, which is our past, last year's spring rocket. It's about 6 inches in diameter, went to about 44,000 feet. Launched out of Mojave Test Area in Mojave, California. And as a team, we also like to prize our motto of raw materials in, flight-ready products out. So again, we try to make everything in-house. Everything is designed, printed, or manufactured, or made in-house by our students and led by our students, right? There isn't much faculty or, teacher insight into, or direction in what we do. We are a very much student-led, student-run team, and I'm very proud of that. So, yeah, AIAA members also take part in this. I know a few of them who are in both clubs, in both AIAA and also RPL, including myself, and we have a great time doing it.
The USC chapter of the Society of Women Engineers, also known as SWE, is great for building leadership skills, providing leadership experience, and creating opportunities for exposure to top industrial and educational leaders for collegiate members. With sponsorships from many large corporations such as Google, Boeing, PwC, and Northrop Grumman, students get to attend the national conference, social events, networking workshops, volunteer opportunities, and so much more. SWE currently has over 400 members from all engineering majors here at USC, with both undergraduate and graduate students. National conference attendees were able to network with industry professionals for career opportunities last fall, and we had some fundraising events where we got to purchase and donate STEM kits to girls in the LA area around Christmas time.
Another one of our student design teams include the Aero Design team, and they compete in the AIAA DBF competition every year. ADT was founded in 1991, and in this past year's competition, they placed top 5% out of the 97 total teams. To build their plane, they must adhere to the competition rules, which are different every year. So they use several softwares as well as manufacturing techniques and the theories and principles learned throughout the engineering curriculum to help them build the plane.
Another student design team is USC Racing. Different departments of the team work on specific parts in order to design and build a Formula race car from the ground up. Annual competitions are hosted by Formula SAE, where schools from all across the world come together to compete in autocross events. Although it is primarily an automotive team, many aspects of aerospace are still involved. The composites team uses carbon fiber to develop aerodynamic components of the car. Extensive computational fluid dynamics is used to model these aerodynamic forces, as well as to improve efficiency of fluid flow within radiators and intakes of the race car.
Putting a bit of a highlight on our branch here at USC, I want to talk about stuff we do, kind of what our goal is as a club, right? So as a club, we want to leverage the networks within and beyond, of course, the LA area to provide really cool opportunities for students here at USC, right? So whether they're in engineering and aeronautics, astronautics, or whatnot, we want to provide really, really cool tours and engineer meetups, meet and greets, whatever else to our students. Knowing that recruiting is hard, it's always hard, always will be hard, right? But we can add a bit of a dampener, right? For kids who are having a tough time, right? So that means doing a newsletter, that means doing meetings for the club, that means doing tours of shops of companies that people may work at, right? These kinds of experiences are not only cool and fun, but also provide a really good insight into what an actual job might be once they move out of college life, right? So getting a step in, getting a peek into the industry is important and is really critical in making a really good program, right? So that's what our goal is.
And actually, even though they cannot be here, we have a council member, Daniel, who's a USC aircraft safety specialist.
Yes. Meet you.
Okay. Moving on to the next presentation, the itinerary, we have Dr. Naum Melamed. He's going to give us a quick intro to Aerospace Corp and planetary defense.
Thank you.
Doesn't matter. Oh, here. All right.
Perfect. Thank you. I'm going to talk about planetary defense, about aerospace corporation in which I work, and about my day-to-day job, which might be of interest to you. But before that, let me just make sure that we are not going to hit by an asteroid during my talk. So this is JPL's website for near-Earth objects. They maintain up-to-date database that is being updated with asteroids that are zipping by our planet as we speak. And today is what, the 11th, I think, right? So we are lucky we have an asteroid that's going to impact with us in the next couple of days. About 17 times the distance to the moon. And then a day later, another object that's going to zip by at a few times the distance to the moon. So we are fairly safe here. All of these objects are not going to collide with us in the next half an hour. So I invite you to go visit this page. It's been updated every day by JPL based on observation data that is coming from telescopes, both professional, amateur telescopes. So they're all being put into the database here, and we are going to talk about it later. We are safe. You can filter those based on size, based on distance, based on time from impact, and we're going to talk about it a little bit later. But let's move on to who I am. So I've been working for the Aerospace Corporation in the last 20 years. My current main day job is working on the Artemis rocket that is going to the moon. I'm sure you heard about the Artemis project. We had one successful demonstration mission a few months ago. We are now working on number 2. which it's going to include astronauts on board, not landing on the moon just yet, just making sure we can fly them around the moon and bring them safely back to the Earth. And number 3 will be landing them on the moon. So I'm on this project, and aerospace is involved with that. It's part of this project, which is right on this page here. You can go and read about it. So my presentation here, let me tell you about my presentation. It's going to be mostly going and visiting several interesting websites. The reason is that anything that I pick out of the websites have to send through the clearance process, which could take weeks and months, and by that time it's not up to date. You cannot check what asteroids are zipping by our planet right now. So I'm going through those interesting websites live. We don't require any special clearance. But I'm going to show you some of the studies that we've been doing recently and have been released for public viewing at conferences and journals and things like that. So here it is. This is the page about the Artemis. I invite you to go and visit this page and read it about what we do. I'm part of this team. What is planetary defense? Planetary defense is basically something that we discovered just in the last few years when we started putting radar and telescopes into the deep sky and seeing that space is not empty. This is an excellent resource page. It's the NASA Planetary Defense, how do they call it? Planetary Defense Coordination Office. It's the office that manages all of the official US government activities on planetary defense. It includes description of missions, links to other centers, both domestic and international, and it tells you what planetary defense is. So I'm really inviting you to visit this page. It's a wonderful read about what those asteroids could do. Another NASA center is the Jet Propulsion Laboratories. They have a center that's called CNEOS. This is really a cool name. It's like Center of Near-Earth Object Studies, but it's also CNEOS, see those objects as they zip by our planet. So it's a double meaning here. They give news about different discoveries. Here are some breaking news. We're going to visit this page a couple of times during this talk. The first one was the very first page where we looked at those asteroids that are zipping by our planet, luckily not impacting with us today. Aerospace also is involved by the company that I work for. We are doing several things. So one of the things that we do is educational outreach. I think some of you have seen are involved with STEM talks and STEM activities to schools. I have been giving this to hundreds of schools during my 20 years at aerospace. I talked to thousands of young kids, 8 to 80, and I saw their eyes popping out, and I know that I inspired some of them to become involved with careers that are related to STEM in the future. So I think this is a good thing to do. The other thing that I've done is that through a class that I developed at aerospace, one day a couple of IMAX movie producers landed in my class and said, "Can we put your class in the movie?" And so there is a movie that's called Asteroid Hunters. It's showing at the California Science Center. And you're all invited to go watch it. You might recognize somebody in the movie. And I'm not going to play the trailer now, but you're invited to Google that and see what the movie is all about. It's 3D about asteroids, like flying through fields of asteroids and learn about what they can do, what we can do against them, how we discover those. Very, very interesting documentary, 40 minutes long, showing at the California Science Center. We are also developing an app that helps us understand how asteroids can be deflected from colliding with the Earth using orbital mechanics and launch vehicle performance embedded into a special tool that we developed. I'll give you a very quick demo a little bit later. We're also employing some science into this. So artificial intelligence has been applied to discovery of asteroids from archival photos of the night sky where the human eye or even automated programs cannot quite pick those dots of light that are moving across the fixed sky. But artificial intelligence type of algorithms can detect those things that are just not visible to us in a standard way. And finally, in terms of inspiring the next generation of scientists and engineers just like you, the best place to start is at home. So me and my son have been collaborating. My son decided to study political science. I said, okay, let's combine the policy aspect with the engineering aspect. And we have been writing papers together about the policy of planetary defense. I think we have 3 or 4 papers so far. Some of them are in the journal. And so start at home, inspire your neighbors, siblings, friends to do that. So I have a father and son bonding with my son on planetary defense. Okay, so looking at this moon of Jupiter, we can see it was bombarded by large objects that collided with the moon over its lifetime. So we are living in a dangerous neighborhood here. I'm sure that some of you have put a telescope to the moon and you've seen some of those impact craters on the moon. And the moon is really in our neighborhood, right? It's very, very adjacent to our planet Earth. Whatever happens to the moon surely has happened to our planet Earth on which we live. The only reason why we don't see so much evidence is because on the Earth we have geological activities that tend to erase those evidence. But on the moon, they are preserved forever. We can see what the moon has suffered over its lifetime. We are in the same kind of situation. So what actually does collide with us? The US put out satellites to detect explosions in the atmosphere, and those explosions are not necessarily man-made. A lot of them are made by objects that collided with our planet that come from the interplanetary space. Except most of them are very small. They just disintegrate upon entering into the atmosphere, release their energy. We're going to talk about one specific one, which is this red dot here. It's quite energetic. It happened exactly 10 years ago over Russia. I'm not sure if any of you knows about it or remembers the explosion that occurred over Russia 10 years ago. That's the one. As you can see here, over about 3.5 decades, let's see how many were discovered. 947. So quite a number of actual impacts with our planet. Luckily, they are mostly small, and so they don't cause any damage. And a lot of them end up over the ocean or in the desert or in uninhabited areas, so no damage to life and property, but it's a possibility. Recently, NASA also started another survey program. It's done from geosynchronous satellites that are intended to detect the activity of lightnings in the atmosphere, but they are able to detect explosions that come from cosmic objects as well. And over the last about 5 years or so, they found over 5,000, right? 4,000, right? Which is much larger number of objects that are actually colliding with our atmosphere. They're all small objects. They don't cause any damage, but they are just a demonstration of the type of neighborhood in which we live, right? Let's start from old history. So today we are aware of about 200 impact craters on the Earth. Some of them are quite large. I'm not going to go through those Wikipedia pages. This is just a starter for you if you want to explore a little bit more. I'm sure you've heard about the extinction of the dinosaurs that occurred in the Yucatan Peninsula over 66 million years ago. Luckily, this is a very far in between type of event. They're estimating one in every maybe 100 million years. So we have another 30 million years to worry about this kind of event. So we are good on that one here, not in our lifetime. However, if we move forward in time, we come across a meteor crater. Have any of you visited or know about meteor crater? Do you know about this crater? It's a crater in our neighboring state of Arizona. It's called Meteor Crater. It looks like that. It's about a mile-wide crater. It's the best preserved impact crater on the Earth. I really invite, if any of you is planning to visit the Grand Canyon or just North Arizona, Flagstaff, it's a beautiful area, take a few hours off your trip and go visit this place. It's not very far from Flagstaff. You'll get to visit this crater. Let me go down. I think there is a very nice big photo of the crater somewhere around here. So this is a view from the visitor center at the crater. You can see the desert is largely just flat, and about almost a mile wide impact crater is just embedded in the desert floor. You can walk around the edge and appreciate the force of nature. They have a wonderful visitor center. You get to read about the history of those asteroids and comets, and touch big space rocks that came to Earth and are now preserved in the visitor center. Really highly recommended part of a trip to this area. So recently a neighbor had a guest, and we just started just casually talking about asteroids and planetary defense, and she said, I'm from the country of Estonia, and we have an island with a few impact craters. And I said, hey, let's see. So I looked it up, and sure enough, there are a few impact craters in an island near Estonia. So I'm now planning a trip to go there one day and look at those impact craters. I think it's really a good thing to see something which is really relatively fresh, relatively small, but very, very nice. So this was a news to me. Have you heard about the Tunguska event in 1908? If you are raising your hands. This is an explosion that occurred over Siberia in the year 1908, where an object came without warning, exploded in the atmosphere, and essentially leveled about 2,000 square kilometers of Siberian desert. There are famous pictures of showing the desert, the forest trees are completely burned out outside of the epicenter of the explosion. It did not create a crater, it just exploded in the atmosphere. But it destroyed about 2,000 square kilometers, which is bigger than most big cities with millions of inhabitants. Those cities would have been burnt down within a nanosecond of such an explosion. That's where the concern that comes from those objects that show up without any warning, like the Tunguska event. In fact, Moscow was very, very lucky. If that event had occurred just 3 hours later because of the rotation of the Earth, Moscow would have been gone in an instant, or potentially Brussels, or I think even some cities in England would have been all gone. They are on the same latitude. It would be gone. It's just a question of timing. So that's the concern that comes from those objects that the community of planetary defenders has been established.
What if it happened over a Bitcoin area?
Somebody would lose his pocket. Chelyabinsk is the event that I mentioned a moment ago. That is an explosion, again, over Russia. Russia is a very large area in size, country. So it exploded with no warning. The reason why it wasn't discovered is because it came from the direction of the sun. And we just cannot aim a telescope into the direction of the sun and expect to discover objects coming from this direction. This is a big gap in our defense. So I'm going to show what kind of things NASA is planning to do to try to put sensors in space that will try to detect those objects as they come to us. So even if we cannot deflect them or destroy them, at least we can give a warning for evacuations, so they don't explode with zero warning and can cause major damage on the ground. NASA has a very nice little documentary that they did on this. Shall we play it? Do we have a few minutes? Let's see if we can hear that. Do we have sound? I don't know if we have sound here. This is
You have to click more on the right. More. Share sound.
I cannot see that.
Oh.
Down, up, right there. Yes.
Yes.
Okay. Yeah. No sound. So just Google that. What happens over Russia? What was the title of it? It has a lot of dash cam videos that show with some sound that you miss here from that event that occurred in classrooms, in offices, This is a real event, just 10 years ago, in our lifetime. This type of event is estimated to occur maybe once or twice a century, which means that any of you could experience something like this during your lifetime. And it could destroy an office, a part of a city. That city was very, very lucky because the object entered through the atmosphere very, very shallow. So it exploded at high altitude and released energy at a high altitude. But the more typical case is that the object would come steeper, release the energy at a lower altitude, and could destroy part of the city, cause mass casualties and mass damage to properties. So this is just the kind of detectors that were used to sense the shock waves that this event had occurred on had caused on the ground, and it's kind of what elephants can sense, right? They sense very, very low frequency type of vibrations. They have sensors that are designed to detect those type of activities. So the object, the interesting part is that on the same day there was another object that was projected to zip by our planet and not impact with us, which actually did happen. But the same morning, an actual object did impact with us, and oh, the scientists messed up. That object had energy of 20 to 30 times more energetic than the Hiroshima explosion, which means that if an object like this had exploded over a city like Hiroshima, it would have erased the city almost completely. Same amount of energy, but no radiation, obviously, but it's same amount of TNT embedded in it. So I think let's just move off of this because they just don't have the sound. So let's see, how do I do that? Can you hit escape and maybe just link it? Oh, here it is. Okay, there we go. Oh, here?
Microphone guy.
No.
No.
Oh,
That's not the one.
No. Okay, so let's move on. Where were we here? Are we on? Oh, here, okay. So I was sitting at the conference thinking the conference occurred just 2 months after that event, almost 10 years ago. We are holding planetary defense conferences, and there were experts showing simulations representing what would have occurred if the object had entered steeper into the atmosphere. And I said to myself, if we could only intercept that object at a higher altitude, then perhaps we could save the day over a key area. You have ways to intercept incoming adversary missiles. Why not use the same technology to intercept asteroids as they enter through the atmosphere? So we held a study in which we looked at exactly those concepts. It was funded by NASA, and we presented it to NASA. I'm going to skip most of it here and just show roughly what it would do. This is just the background of that event with some of those videos. This is an interesting thing. At the time of the presentation in 2018, about 18,000 of those near-Earth objects were known to us. I'm going to show you in a minute how many are known to us today. Just remember the difference in those numbers between about 5 years ago to today. So let me skip most of it here, just in the benefit of time. I did kind of survey. And so what we've done here is we looked at the actual object that entered. It looked like this. The energy was released at about 20 kilometers. If the object entered at a steeper angle, the energy would have been released at about 10 kilometers of altitude. This would have destroyed chunks of that city and probably killed many thousand. So let's just try to intercept the object a few kilometers higher, and we almost can save the day over that city. That's the whole idea. So we looked at those type of vehicles that are designed to impact approaching, ICBMs and so on and so forth. Why not do the same thing for an asteroid? So we actually showed that it is possible to do. in concept. We are not doing any of the engineering, which is very complex, like you heard this morning, where you actually do the actual design. We're just looking if the physics is there. And the physics is there. We said, well, we need to build a system that has the major components, just like every space operation system. We actually took the statistics out of those objects that physically impacted with our planet. We took the ephemeris from them and said, let's imagine those are larger objects that we really want to destroy upon entering into the atmosphere, right? Just imagine they're slightly bigger. So we took the statistics out of there, and we looked at different studies that correlated the size of the asteroids with their composition, what are they made out of, things like that. And we devised the sequence of events, right? So what would happen is that within very short, within minutes essentially, we need to detect it, calculate the firing solution, put it into the flight computer of the killed vehicle, launch the killed vehicle, and try to intercept the upcoming object at 100 kilometers, 500 kilometers, just minutes before it will explode over a key city that we would like to defend. And we showed that that is possible. We looked at specific types of radars that would have to be built to detect those kind of objects, ground operations, and so on and so forth. And the basic idea here is that if we did nothing, we release the energy just above that city, and the city will be destroyed, versus intercepting it at a higher altitude, essentially breaking it down into smaller pieces that will increase the surface area of the object and cause the energy to be released at a higher altitude, let it disperse over a larger area and save the day over this key area. We looked at the entry conditions and the amount of energy that is required. So the interesting thing is that we can use one single system to defend the entire US if we have 1 hour of alert from detection to the time of impact. So we have time to defend the entire continental US, which is a good thing. But we also show that if we have less than this time, we would have to have multiple systems. If we have half an hour or 15 minutes or even 3 minutes, we can actually defend a specific city if we have a system located at that city and discovering the object at 3 minutes to impact. That's amazing. You can actually save the city with this type of system. So maybe one day one of you will build this kind of system. We left a lot of this to future work. Let's see, what else do we have here? We have a simulation that's running that's showing that this is a full-blown simulation with the orbital mechanics in the calculation that shows that we can actually intercept the approaching asteroid with realistic velocities and accelerations that are available to those kill vehicles. Everything here is physics-based. Let's see, anything else is in here. There is a nice video, but I don't think it's showing here. And all of that is just a lot more like Monte Carlo type of studies that we've done to build those ranges. Also, we looked at what to do next. So there's a lot of work to be done in the future here that we didn't have a chance to cover in this particular study. Let's see. Oh, okay. So this is the reality in which we live today. So as of what happened here? Okay. As of yesterday, right? As of yesterday, we are aware of over 31,000 near-Earth objects that are known to us, from 18,000 5 years ago to over 31,000 today. And the rate of discovery is actually accelerating, with more and more telescopes being put up into the sky to discover those objects. So we think that there are probably hundreds of thousands of those objects scattering around the solar system. And our objective is to find them before they find us, right? We would like to have that kind of situation, but we really kind of live in the dark ages now in that sense. for another couple of decades until we are able to find the majority of these objects and hopefully be able to do something about them. But the reality is that we could hit by any of these objects with essentially no warning anytime now. This is part of the concern that the community of planetary defenders is dealing with.
Plus, our adversaries have been shooting our satellites down, creating a lot more debris up there.
But that's a different kind of debris.
Yeah.
That's not the same kind of debris. Every object that is being discovered is being put into a database that's maintained by the Smithsonian organization in DC. Anybody can go there and pull out data with the ephemeris associated with any of these objects, and they can do statistical study, they can pick specific objects and try to design a mission against this type of objects, which are representative of what could happen any day. So, okay. Here is a mission, one of the missions that NASA is pursuing. It's called the NEO Surveyor. It's a satellite infrared sensor that would be put in the Lagrange point 1. You know what Lagrange points are? These are stable points between the Earth and the Moon, where you don't need to do a lot of station keeping on the satellite to keep it roughly in the same place. If you put an infrared sensor right there and look into the Earth, you see the illuminated side of those objects by the sun. You measure the heat that is being emanated from those objects, and able to discover them perhaps 1 or 2 orbits before they come to impact with us. We have a chance to do something about it, or they could issue alerts. Yeah, be careful, in a week or 2, there is an object that is going to collide with your city. At least save your life, evacuate out of the city. Right, that kind of thing this is intended to do. So I'm sure that if you look at those plots in 5 or 10 years, they're going to be a lot more mature in their information because of the sensors that are being put out there today. How to test any system. So the DART mission occurred a few months ago, very successful. NASA launched a spacecraft that collided with the asteroid. I'm sure you followed a lot of it, and you know the reason why it was selected. And basically, I'm just going to say that the basic reason is that they were, obviously they didn't want to do any harm, right? So they wanted to deflect an asteroid that is harmless to the Earth, just to demonstrate the capability to do that. And they elected to do that to deflect the companion of a binary system, the moon of a big asteroid. The reason why they did it is because by doing that, they caused the orbital period of the small object around the main object to be shorter by a certain amount of time. And the reason is that we can measure that period from the Earth. We don't even need to go out to this area and know what happened. And that is how they measured the success of the mission. They were able to deflect it by a lot more than was calculated, in fact. So we can do that. We have the basic technology to do that. To understand what's going on and get updates from all around the world, we hold international planetary defense conferences every other year. I'm participating in the organization of those conferences. And in a couple of weeks, we're going to go to Vienna and hold the conference at the Vienna UN headquarters. I don't know why this doesn't upload, but this is some problem with the Wi-Fi, I think, or at least international Wi-Fi. Hopefully we didn't lose the Wi-Fi here. So if any of you is interested to know what the conference covers, it's going to be streamed live from April 3rd to April 7th. Oh yeah, it seems to be connecting again. So we probably lost Wi-Fi. Okay, something came up. This is the page for the Planetary Defense Conference that we held in 2007. All of the presentations there are available, so you can look at what was presented. All of the presentations are recorded. You can listen to the recordings if there is any particular area that is of interest to you to see what was talked about. It's all available online. You can go and visit and listen to the conference. Did it come back? You know? Oh, yeah, it came back. So here's the conference. It's in 22 days. So in 2 weeks, I'm going out for the conference. I have a paper there and one of the organizers of the conference. Here are the topics that are going to be covered by the conference. You can look at the program, by the way. Let's see, these are the basic activities each day of the conference. These are the different areas. We are trying to maintain a very broad range of activities and talks during the conference to cover not just the technical part, but also the discovery, the characterization, the political, legal, public, disaster response, everything that is associated with the area of planetary defense we would like to cover during the conference. Very interesting conference and very relevant to some of us potentially one day.
Anything ever come out of it?
Of the conferences?
Yeah.
Yes, a lot of recommendations. Some of the recommendations actually got implemented. And I think one of them was the establishment of the NASA Planetary Defense Coordination Office, where it came from one of the early conferences. We need an official government body that will coordinate US activities. That was one of these. But if you go to the final reports of each of these conferences, which are available on this website, you'll see what kind of observations and recommendations came out of those conferences. Some of them were implemented, some of them are not implemented yet. I mean, these are big projects, mega projects, and there are several fires that are occurring around the world right now that suck up some of the attention and resources. So, yeah, that's the reality in which we live. Yeah, that's it. So, not yet. One more, couple of more slides. Each conference we hold a realistic exercise in which JPL and several other organizations are creating a scenario which represents what would happen under specific conditions. And that scenario is studied in every conference. We have one that was created for the Planetary Defense Conference of this year. Sometimes we hold just tabletop exercises, TTX, where it's more like domestic type of activities between NASA and FEMA, where the, let's say, the space community talks to the disaster response community and kind of communicate between them what they would do in the case of an asteroid threat. So that's all covered here. You are welcome to go visit those pages. So in one of the cases here, in 2000 and which one was it? Yeah, 19, there was an interesting two different scenarios, an asteroid and a comet. The problem with comets is that they come from the outer regions of the solar system. So they're being discovered very late in the game, maybe less than 2 years before impact. They are coming very, very fast because they're coming from much higher altitude than typical asteroids. They could fly, they could move at speeds of 40, 50 kilometers per second. They are bigger in size, so they are much of a concern. They are fewer in number, but they are probably equal in the level of threat because of their size, the late discovery time, and so on and so forth. So there was a comet scenario that was put out just to see if anything could be done. This is the case where the hypothetical comet impact scenario. You cannot reach to this comet with a chemical rocket, with a regular rocket, simply because the comet approach from high above the ecliptic plane. No rocket can turn like this in a short amount of time to intercept an object that comes outside of the ecliptic plane, the plane of the Earth around the sun. What can you do if you're faced with a situation like this? You know, some of us just sit down, we need to find a solution, right? And we did. We saved the day somewhere. So this is a study that we've done for the conference, where we looked initially at launching a rocket at this comet, and we found that this cannot be done. The amount of time it requires to intercept that object with a chemical rocket is between 2 and 3 weeks before impact. That's way, way, way too late. to do anything about it. We said, let's launch more than just one rocket. So we tried to launch 30 NASA SLS rockets. You know, those are the boosters that launch the Artemis into the Earth, right? And we were able to move the object from the center of the Earth about half radius. That's not a solution, right? That's not a solution that's acceptable. What can you do? So one of our guys came up with the idea of solar cells, which uses the radiation of the sun to push on the cells. And so there is a company right here in Southern California that builds those type of steerable solar cells. You can pack them into the launch vehicle, like so, and deploy them in space like so. And then you can launch them from the Earth to as close to the sun as possible to let the pressure of the sun push them and adjust their orbit. The basic thing that you can do this way is you can do an orbital plane change, which is very, very difficult to do with rockets, but with the large amount of plane change, right? Every orbital mechanic expert knows that. So, but with solar cell, you can do it. And we've done it. And we were able to intercept the object at 2 or 3 astronomical units at several months before impact. Now here you can explode maybe some nuclear device and destroy the object before it comes to impact with us. And I think I have a little animation. Yeah, so here's a little animation of what we've done. Again, all of that is based on the orbital mechanics of the case. There is no engineering in here. It's just a basic physics, orbital mechanics to show it can be done, taking into account the radiation pressure of the sun onto the orbit. So right here, that causes the orbit to basically change its planar, its plane by about 10 degrees each orbit. And after a few times, you find yourself on the intercept orbit with the incoming comet. And at some point, it transitions to the outbound part of the orbit here. All of that is done with steerable solar cells, right? You just steer them and control the direction of the vehicle this way. And now the object the spacecraft is headed out to intercept with the incoming comet at about 3 astronomical units. Potentially, it's a solution to the problem. So we can deal with comets as well. And here's the incoming comets. We can intercept an incoming comet at a few astronomical units from the Earth. Another thing that we are doing right now, have you heard about the company that's called Spin Launch? Right, you know what they do? Anybody visited their facility by any chance? Oh, you did? Excellent. Did you work inside the centrifuge? Oh, that's a cool thing. So they have this big centrifuge there. They spin small payloads tremendously fast and launch it into space. So they claim, but they were able to do a suborbital, and I think they got from NASA some funding to do a bigger experiment soon. And they invited me to give a talk. I gave a talk, and I said, you know, can we use this on an asteroid? And we can. Turns out that we take a small spinner like this. We don't need the big centrifuge. We can just use a small spinner, put it on an asteroid, grab pieces of rocks from the asteroid, throw them away, and over time generate the momentum that is required to push the asteroid away from the Earth. So we did a little study that we are going to present at this coming conference in 2 weeks, where we put a spinner like this on the asteroid, and we can deflect a Chelyabinsk or Tunguska type asteroid within a few weeks of operation. So that the basic physics is there. Now, how to anchor the spinner to the basis of the asteroid, this is all engineering problems. We didn't even start to deal with those complications. But the basic physics is there, the basic momentum exchange is there. So we're going to present it and see what kind of skepticism we'll get from the conference people here. One of the things that we were encouraged is that just by looking at the pictures that came from the DART mission as it approached the asteroid, I mean, it's scattered with thousands of small pieces of rocks that are waiting to be picked up and thrown away from the asteroid. that kind of system would work very well with this type of environment. And most of the asteroids are made out of pile rubbers that accumulated over millions of years into those big objects that you can just break them down and move them away from the Earth. So this is the exercise that we are planning to do during this conference. You're all welcome to go and visit this JPL page and read about the upcoming exercise. We'll see how it's going to be done. The interesting thing about this exercise is that it's going to be held in the UN headquarters, where hopefully some international delegates of global communities are going to come and act as decision makers. What would you do if in your country that kind of object had exploded? So we kind of try to exercise a global process for planetary defense. That's why we call it planetary defense. It's the defense of our entire planet. Here is the tool that I mentioned that we are developing with NASA JPL. So this is an asteroid deflection app. Anybody of you is invited to try it out on your desktop or laptop at home. You just go to the JPL website here and search for NEO deflection app. And what you see here is an object that is part of a list of simulated asteroids or comets, which tells you the, I guess, yeah, okay. So here is the physical Earth in blue and the red capture zone in red. And this is the impact point without doing anything. Your goal is your mission. You're going to be a mission designer here, an asteroid deflection mission designer. It has orbital mechanics embedded in the engine. It has launch vehicle performance embedded in the engine. It's all first order. Nothing of this is high tech, but it gives you the ballpark of what you can do to deflect asteroids. So you just can move some of those knobs and try to move this green dot out of the red circle here. I'm going to leave it at that because of time. And I think I'm almost done. So here is me giving a talk at a local school to students. A couple of those students approached me after the class and said, I'm going to study space engineering. Success. Let's see. And we are hiring. If any of you is interested in working for a company like Aerospace, you can approach me. You can point your phone at this stuff, and we take interns, we take fresh out of school. So you can reach out to me. What I typically do with those that are interested, we just go and visit the Aerospace career page, see what kind of requisitions are available at the time, and we can see how to tune up your resume so that you fit that particular requisition. And sometimes I know the hiring managers. I can send your resumes to those hiring managers, and hopefully something will come out of that. So if any of you is interested, reach out to me. It's very easy to find. You can talk to Ken, and he can tell you how to reach out to me, or you can talk to me after the talk. With that, I'd like to thank you very much, and safe planet, please.
Thank you. Great job.
Thank you.
Ken, do you have 10 minutes?
Sorry, we have a speaker.
Oh, we have more?
Yeah, we have a
Oh,
speaker.
good.
Sorry.
Wow.
Quick.
Wow.
So just going to take some time here to, again, thank you, Dr. Melamed, for doing your presentation. This time I was a lot more optimistic. Glad to know we're working on the problem of, trying to solve planetary defense. But here we want to recognize you with a certificate of appreciation. We're very happy that that you come and support us year after year, and the section is very appreciative. So. I'm not too sure what this is.
Well, that's with the same design.
Yeah.
That's available, but it's on the paperweight.
Okay, so it's a logo of our section, a paperweight logo of our section.
Thank you so much.
Thank you, Dr. Melamed. All right, up next we have Mr. Dennis Lum, am I pronouncing that right? Founder of Debashi Consulting, and you're here to talk to us about the integration, test, and launch of space rockets.
So as we get this going, I apologize. My slides are probably a little memory intensive, so it might be laggy. But we'll make it through. It's not as intensive as the last one, so.
You already put these? Oh,
Yeah, I'm already using mine.
okay. They should be ready.
Let me go all the way back to the top. Okay, since everybody's seen the slides already, we're gonna go really fast now. Okay, so everybody knows my name. I'm gonna give you a little brief introduction of who I am, what I've done, just to kind of give you a little career aspect of what's possible out there. I did not really follow the traditional engineering where you get out of school, you know, graduate from USC and go straight to Raytheon or Boeing or somebody like that. So I'm just gonna kind of talk about some of these jobs that I've done, what exactly is there and what's possible.
No?
No? All right, you might have to do it for me then. Next one. Okay, so when I first got out of school, like I said, did not go straight into one of those typical engineering companies. I actually started with the US Navy as a contractor. Oh. I actually started with the Navy as a contractor working on ballistic missiles. From there, I moved on to working with NASA on the hypersonic vehicles. And then I spent the bulk of my career with Northrop Grumman building satellite and space products. I can talk about some, others I can't talk about. But this one that you see right here, was L-Cross. Proud to say that we're the only program that actually did 2 bombing runs on the moon to look for water. And we did find a lot of water, so like I said, some exciting stuff that you can do. And then before I left Northrop a couple of years ago, my last job was to build a modernized production facility, make sure it's efficient, insert new technologies like robotics, augmented virtual reality systems, so that when we produce these satellites and space products, that it's a lot more efficient than the way that we're currently doing it now. Okay, next slide. So I'm going to really talk about satellite integration, test, and launch. This is one of the organizations that I had the privilege to work for many, many years. This is probably my favorite, just because you get to do everything. I don't know if anybody's really heard about this organization, but this is as close to jack of all trades engineering as you get. You work with everybody, from senior leadership to customers to payload providers to engineers to technicians, everybody across the board you have to work with in order to succeed.
So you're an Atlas guy.
We work with them too. So what do we really do in integration? I'm going to pass manufacturing, I'm going to pass proposal world, and we're going to go straight to integration. So integration, you liken it to building a Lego set, except you have to write the instructions. You get a drawing and you have to put it all together. So you receive all the parts, you receive all the subsystems, you receive the payload. You are managing your tasks. You're making sure it gets on properly, you make sure it gets recorded properly. If anything happens, it's up to you to fix it and work backwards with the provider or whoever was the manufacturer to ensure that it's correctly fixed. There's a lot of stories that I have here. Like one, for example, we received a panel, a carbon fiber panel, honeycomb panel, and when we were doing resistance measurements, for some reason we couldn't get a resistance measurement. that really, I mean, like, it takes a hit on your skill set right there. You're thinking, what in the world? I can't figure this out. So what happened was that the manufacturer clear anodized it, didn't tell us. And that wasn't even our requirement. So we lost days on that kind of stuff. And so that's why, you know, I'm not going to go too much into why it's important, but it really is to know your suppliers, what you're doing, why you're doing it, and who to go back to, and why you chose those people. Okay. Next one.
You use Fisher thermodynamics to find out what the element was? You know, the X-ray, you know how the
No.
trace element?
Yes, well, we do here, but I'll talk about that in a minute. The only reason that we found that out is we looked through all of our documentation, we couldn't figure out, so we decided to blindly call the manufacturer up and to say, how did you make this? And then at the very last thing, they told us clear anodize. We're like, that's it. That was it. We probably lost like hundreds of thousands of dollars in schedule time just because of that. But environmental test. This is probably one of the most entertaining parts of integration, where you get to shake it, bake it, freeze it, just to make sure that it works properly. And if anybody's ever seen a dynamic test, when you're putting a whole entire vehicle there, it's shaking so violently, it's like your umbrella in a windstorm, and you're surprised that nothing comes shattering and breaking off. Some things do come off, but you know, that's for another story itself. But that's for like vibration test, acoustic test, same way. We put it inside a chamber and we blast sound waves at it, because the kind of environment when we put it on a rocket and it goes out, it's extremely volatile in there. I mean, it's very, very harsh environment, so we have to make sure that it's going to survive in launch. And thermal vacuum test. So thermal vacuum test, going back to what you were saying earlier, there's certain materials that's prohibited in thermal vacuum testing. For example, zinc, tin. And these are the kind of things that you learn in your materials class. You don't want it in there because when you get the hot and cold, it starts to whisper. As it whispers, it will touch a circuit and you have a short circuit. So these are the kind of things that you learn as you go and you work with all these different people. Okay, next one. So after you get through all of your testing, we're going straight into containerization. Now, mind you, I'm building a whole satellite here in like 5 minutes, and it usually takes years. So this containerization, once you're done with all of your mechanical testing, all your mechanical integration, and you get all of your system engineering buy-off from all your verification and validations from the customer, you know, we get the go-ahead, we're ready to go. We're ready to go ahead and pack up and go off to the launch site. So we begin our containerization. This is also part of our group, and this is what we do as well, is we place the vehicle inside a container, we ship it by truck, plane, train, whatever, boat on James Webb, whatever it takes, that's what we do. We ship it out. And not everything goes according to plan. I'll tell you that as well. One of our satellites hit a guardrail up in Ojai going to Vandenberg. So I got a call at 3 in the morning to start heading up there. So that was my program. So 3 in the morning, jump in the car and start driving up to Ojai to see what happened. Right? Like I said, you never know what happens there. Okay? And then, we also pack the whole entire factory. So most people think we just ship it off and then people fly over. Nah, all of our equipment, I would say probably good 80% of our equipment, our people, equipment, everything, consumables, everything flies, it gets packed up and delivered up to the launch site as well. Especially our red tag, green tag items. So those are those who are familiar in the aviation world, red tag and green tag items. Red tag items, things you got to take off. Green tag items, things you leave on. Very, very important. If there's one thing that you got to get right, that's it right there. You don't want to leave something on that's not supposed to be on. For example, we've actually left on a cover, which somebody built to look like MLI, which they shouldn't have done, so that we didn't know what it was, because you can't visually see it. It blends in with the rest of the vehicle. So we had a problem with that. But red tag, green tag, very important. Okay, next slide. Launch campaign. So as we prepare, we have to, so it depends on which vehicle we go on. We go on truck, we go on a plane, we go on a boat. We prep the vehicle differently, right? You go on a plane, you have to make sure of air pressure differences to make sure that the environmentally sealed container doesn't blow out. So you got to have ventilation holes and so on and so forth. On a ship, not so much, but then you got all the seawater and all that harsh environment. So there's different things that you have to prepare for. There are certain things you can't prepare for. Another story, for example, this C5 right here, when it landed at Vandenberg, as I was waiting for it, the pilot took a turn. When it landed, it took a turn down a taxiway too fast, blew out 2 wheels. So we couldn't level it off, and we couldn't get the vehicle off. So we waited 2 days for them to truck new wheels out from another Air Force base. And because of that, we were putting in K bottles and purging our container continuously for days, right, out on the tarmac. So let's just say that pilot got a good talking to by their superiors. Because for us at that point in time, every day could be hundreds of thousands of dollars of delay. And if we delay beyond our launch date into somebody else's, then we got to negotiate or we lose our launch date. So that's why it's very, very important at that point in time. Very, very critical. So once we unload, once we load the vehicle up and we deliver up there, including all equipment and personnel for relocation, then we fly and we go out to our launch site, whether it's Kennedy, whether it's Vandenberg, whether it's French Guiana, wherever it is we go. Okay, next slide. Once we get out there, we do payload processing. We unload the vehicle, we perform final checkouts just to make sure that nothing really happened to the vehicle during transport. So we check all the shock sensors and everything in there to make sure that nothing was out of the ordinary. We'll download that, give that to our engineers to show to our customers to make sure that they agree with it. Once we're done with the final checkouts, we'll perform some initial red tag, green tag items, closeouts, and then we'll begin our clamp band installation and encapsulation with the rocket provider. So it depends on which rocket provider you use. You use SpaceX, we're going horizontal. You use ULA or somebody else, then we're going to be vertical. So it depends on what your provider is. Okay. And the next one. Next slide. So launch. We roll out to the launch pad. We do pre-launch dry runs. So for those who actually get to go out to the launch site, when you get out there, a lot of people always ask, why do you leave your badges in the front, at the gate? Well, that's in case, if the whole rocket blows up, they know who's there. They don't incinerate your badge. So you gotta leave your badge in, take a different badge, and then you go up there. Not to scare anybody from getting into this field, but that's exactly what it's for. So one of my other ones, X-43, the hypersonic vehicle that I did, it's the same thing. We went in there, left the badge, went into the building with the rocket in there. So I asked the guy at that time, why do you do this? He goes, in case it blows up. Just nonchalant. Oh, thanks. Oh, fantastic. I love it. Okay. So we do our final red tag, green tag items on the vehicle. We're crawling inside the rocket at the time, and we're doing our final checkouts and final red tag items. We got to make sure these are the final ones, because these are the ones that are actually going to be what ignites our explosive bolts or non-explosive bolts to separate the vehicle from the rocket. So if you don't do this correctly, it's coming back down with the rocket. And then we do a launch countdown. So for those who have ever been to a launch, everybody watches it on TV. It's like, oh, it's fantastic. It's so easy, just fire it off. This right here is probably your worst nightmare right here. There's not one launch that's ever gone right. I remember many, many launches where there's one where I probably got 8 hours of sleep in 3 days because it was a 2:30 in the morning launch, scrub. Again, next day, scrub, next day, scrub, and you're constantly recycling the vehicle over and over. And the reason why we scrub, I'll tell you a story here. We played this game what we call Launch Chicken. So what that game is everybody knows everybody has a problem. Whoever raises their hand first and delays pays for the delay. So that means that we as the payload guys and the rocket provider, we're sitting here, we're like, we know they have a problem. Let's see who goes first. T-minus 3 minutes. Fine. All right, our fault, we paid for it. Like, scrub one, that's on us. Number two, we know they haven't fixed theirs. We haven't either. But we're further along, so we're just We're gonna hold down T minus 2. They gave up. That one's on yours. So we got some more time to fix our problem. By round 3, nobody wanted to pay anymore. So we were like, just don't say anything. Hope it goes. And thank goodness most of it goes. So that's how these launch scrubs really happen. And you're sitting there like, the launch has been scrubbed. People wonder why. It's because everybody has a problem. No one wants to admit it. Right? And so that's why it's like scrub T minus 2 minutes, T minus 30 seconds. That's the reason why. Because when you scrub, you bear the repercussions for all of it. All right. So that's pretty much my next slide. I think that's it. Yes. So
I love that ending.
So that's kind of my last slide. Really quick. Like I said, this is probably like 10 minutes. If we really go in depth of all of this, we'd be here for many, many days and months. If you want some more information, I did give a talk, a little bit more detail on integration and tests a couple of weeks ago with AIAA, so it's online as well.
Wonderful. Yeah, I have an announcement to make. Last week I gave a huge presentation to the whole world. The entire Space Force had it, okay, for your general, all of them. That's what I do, right? Space Force and NASA. So anyway, if you could find it on the AIAA site, I noticed even my family can't hold it up because it's been held with help from a lot of people, because we actually came up with a method. My buddy, which is Dr. David Heinlein, he's a quantum astrophysicist, a Kennedy Award winner, one of the best in the whole world. And he's probably taught a ton of NASA people. So anyway, he invented something, and then I just adapted and make it work and stuff. So anyway, it's like the Echo balloon, the original NASA Echo, which was a 41-meter balloon. That's how we, after the Sputnik went up, NASA came up with a Mylar balloon called Echo 1, and it was 38 meters, and then they did an Echo 2 right after that in 61. So anyway, that was 41. We're going to do at minimum 100 meters, but if we did 1,000, we did the analysis on it. If we did 1,000 out of this one material that we invent, it has the power of 200 megawatts and the equivalent of 130 suns. So as a big balloon, it also, because it has solar microwave fabric in little segments, it can actually become a proton rocket with a power of 130 suns for each. Now, the entire celestial body is called the shield. The shield, I call it the Amor of God, because it actually defends all of Earth. We could vaporize any fighter jet, any missile, anything, anywhere in the world at the speed of light. Anywhere. Out in outer space, we can vaporize anything that we said, you're not allowed to be here. Boom, they're vaporized. Okay, so I looked at the entire, this was for clean energy, we invented for that, but also to destroy meteorites, okay? And so we showed it to our buddies at the Air Force Space Command and Missile Defense, and we have a buddy there, his name is Colonel Coyote Smith, okay? And he says, besides that 90 metric ton meteorite, you could vaporize it, nothing. You could vaporize a fighter jet, a missile, anything, anywhere on Earth. So of course we put it all together. I sent it to Trump, and he goes, "Can I have it yet?" So no, it takes a huge amount of R&D. And then Peter Pierce found out that North Korea was shipping a miniaturized nuclear warhead through the Panama Canal on top of a Chinese missile launcher with sugar bags over it, so it was hiding it. So if we didn't stop it, they could have stopped in the middle of Panama Canal, shot it over our heads, had an outer atmospheric nuclear event, and 9 out of 10 people in 1 year would be dead because we be wiped out. So now our solar microwave fabric that makes up this big balloon, it actually, we have bulletproof stuff, the same material. It goes over our power plants in all the susceptible areas like transducers and capacitors, so on. Everything that's susceptible to damage that could put you out of business, like they do in the East Coast, they did in California. A lot of Islamics come in and they shoot out our power plants, and it takes us 3 days to get power back to everyone. Well, this protects it. But the coolest thing, because it shakes hands, okay, because it's retrodirective micro of energy. And for energy, 5.8 gigahertz is the best. Well, anyway, this thing shoots it right down to the power plant. You don't need extra collectors on everything else. I mean, you could have one on your house, on a car, anything, and you could get energy anywhere in the world for free from us. So anyway, we stopped nuclear war. I explained how to do weather control. We can actually control all the weather at multi-layers, okay? Not only that, if we have an entire celestial body, say we do all three orbits, Leo, Meo, Geo, right? So then, now with this 10,000 celestial bodies to handle all the energy in the whole world forever, we can actually move our planet as it's spiraling through the universe. Because remember, these are proton rockets. And at today's calculation, at a super low efficiency of 20%, 130 suns is a lot. So imagine 10,000. So go catch it on his site. If it's allowed for you to see it at the right time, they'll let you see it. So you need to know this, because all these other things, spinning down the wrong path. This is the ultimate way. And then we become the energy supplier for the whole world forever. The United States. That backs our dollar forever. So we did that last week.
Yeah.
That's all.
He was our speaker last week. Well, I'll send everybody the video link. Go ahead. Because Sean doesn't have the PowerPoint here.
It's revolutionary.
Yeah, it's hard for you to visualize. So we'll send you the video.
Yeah, and when we put them up there, as things go by, it'll actually vaporize all our debris. But I don't want to vaporize it. I want to collect it and shred it, and I want to shred it and put it into 3D printing factory up there. We need a factory shredding up all the scrap, everything we can collect. Heck, let's put some of these power stars around a meteorite, a big one, and shoot it on over to our factory and just grind it right there in outer space. There should be people getting up to go to work and fly out to space and come back again 3 days later. It should be really fun to work out there, right?
Thank you, Sean.
Sorry, guys, don't get excited when you're going to change the world the right way.
Thank you, Sean.
In similar fashion, Mr. Long, thank you so much for presenting today. Really appreciate it. I know you've presented in the past, and want to say we really value your input and you being here and taking the time out of your day and teaching something to students. Thank you very much. So Dr. Milliman also wanted me to mention that there are promotional items back there from Aerospace Corporation. Oh, and before I forget, our exhibitor, Mr. Carson Morgan. Hi. We've got a certificate of appreciation for you here too. Thank you so much for taking the time. Haven't had a chance to go talk to you yet, but yes, absolutely. Would you like to say a few words about your company?
Sure. Yeah, I can take a minute or two.
Okay.
So I'll be brief with you guys. Oh. Of course. So real quick, AIAA, we're out in Central Coast of California in San Luis Obispo, started in 2003. I know that I was able to engage with some people about some of our defense articles that we have in the back, some of our small UAS. So I just wanted to let you guys know a little bit about what else we do at AIAA. We are the prime on NASA's X-57 Maxwell. It's an all-electric manned aircraft. We also do AS9100 contract manufacturing, also subcontract work with a lot of the larger defense companies, AeroVironment, Raytheon, companies like that. And we have a singular commercial customer that we have designed and developed a turbine hybrid urban air mobility vehicle for. There's a lot of opportunities to join this small business for engineers, electrical engineers, aerospace, et cetera. So if you guys are interested, I can give you cards and get you in touch with the right people at AIAA for internships, full-time positions, whatever you guys are looking for. Thanks a lot.
Thank you, Carson. Great. Well, it's about that time. First of all, or finally, I just want to thank all of you for your time today. Really, you guys, hope you enjoyed this. I hope you found value as much as I did. I'm really excited for all of the student branches. You are all on a good path towards success. Each and every one of you have demonstrated, or your projects have demonstrated technical depth. I admire your resourcefulness with, the limited resources that you have as students. And most importantly, the relationships I see you guys build between each other. I've had lifelong friends because of AIAA, so I'm really grateful for that. We'll be here. If you need to talk to me or Ken or any of the speakers after the conference is over, we're more than willing to talk to you. But keep pressing forward, keep following your passions. You guys have bright futures ahead of you. Thank you.
Yes. Don's this is my buddy, stand up, Don. I had to invite my buddy from NASA. He's NASA JPL. So, go ahead.
I have thoroughly enjoyed the presentations today. And definitely, I feel like this has been empowering to both myself, Sean, and all of the presenters today that have spearheaded this with being in the industry for so long and dedicating themselves to the progress of the students and all the projects. My part with NASA, I've been involved in various different factors. Right now, we're building templates for the subsystems development, design development, testing, and delivery for instruments, components, and then overall hardware subsystems for spacecrafts and such. So it's a lot of fun, and I think it's kind of more peeling back the onion, because a lot of times what happens is you start to develop a process, or you start to develop a tool. And what happens is, as you dig deeper into it, you realize, okay, this is not just one layer, but it actually expands out and goes a lot deeper than you anticipated. So we can plan something and say, well, it's only going to take us about a year. But then as we go through that process and we dig into the requirements, we dig into the design, which we thought was so similar to something we previously developed, then we realize that things are a lot more complex. And I think that's where the fun of it comes in, because then we have this personal level of challenge, and we're able to engage in a way that we didn't initially plan to engage. And so it calls for a lot of collaboration and learning of new tools and new ways of doing things.
Don't forget the CMMC nowadays. See,
Oh,
people
yes.
in here, everyone growing up now, we have a security problem. I think it's obvious with China and other people after. So she's heading up the CMMC with NASA.
I've got we are
Security, cybersecurity, obviously.
So
That's very important for everyone in aerospace.
So the team that I'm working with, slightly outside of NASA, but we also collaborate. PM United, we are actually a licensed training provider for the CMMC for cybersecurity training, which is based upon the new protocols that are being put into place, to where each and every defense contractor is going to need to abide by these compliance factors in order to stay within contract and be awarded additional contracts by the Department of Defense or any federal
And avoid leaks.
institution. Yes. So if anyone would like any more information, then you can see me.
Thank you all for coming. Have a good rest of your day.
We'll have more about the Oh, glad you enjoyed it. And the bottle of water, we saw you.
Yeah, so actually, that day, I just wiped out. I US 1. I did.